Okay. So today we'll start our first lecture. I don't know if you want me. I'm gonna take my like I said, I'm gonna take the video out just to make it easy for the connection. As you said, like most of you saying that the internet connection is going to be a little bit bad. So before starting anything, I'll just like take my video out. So that's gonna make it a little bit easier for you to get the feed and the recording. So that's it. Okay. So today we're going to start our first lecture. It's actually a course introduction, and like for the students that they say they are not very like, I don't know if they will not really understand stuff like when I'm talking in English. You can stop me at any time, and I will repeat myself and try to explain everything in more details. Okay. What actually our agenda for today? We're going to start with a brief welcome and introduction, and then we're going to discuss like why are we here. We're going to talk about systems. We will talk about systems engineering, and also we will discuss why do we study systems engineering. And then after that, we will briefly discuss the course syllabus. I've already submitted those files through the WhatsApp group, and I have uploaded those files to the folder. We have like a Google Drive folder for the materials of the course, and everything is there. And I will be like posting, or let's say uploading all the files that I will, let's say, have here, either like for exercises, assignments, and everything. They will be uploaded there. I will not post anything in WhatsApp unless it's urgent or necessary. Okay. And like one more thing for the course syllabus, and let's say for details, you have to prefer, like, let's say you have to refer to those files, as there's like a lot of information in these like two files, which are actually the syllabus and the project. So starting with the introduction, I think like some of you are familiar, like they know me, maybe we were colleagues before, maybe I was teaching like some of you when I was like a teaching assistant back there in Taz University. So my bachelor actually from Taz University, and my master engineering I got it from King Saud University. And finally, like my PhD is actually so recent, just defend my thesis on December, and it was like on mechanical and industrial engineering from Ryerson University. This is actually like an academic background. So you know actually that we are all from the same field, from industrial engineering, and we hope to have like it's, let's say, a better understanding of each other. So just like for the sake of attendance and also for the sake of, let's say, introducing yourself, I'm gonna ask you either to like unmute yourself and talk about yourself if you want, or introduce yourself to us, or either just like type your full name in the chat so I can even like take the attendances. So either way, if you unmuted yourself and talked, or let's say introduce yourself, or either like you need to type your full name in the chat or the room chat so I can take the attendance. Okay. So please, yeah, just I will just write the name. So far I have only one name. Does that mean that you really like not listening, or maybe there's a problem with the connection? I don't know.
Yeah, you hear us, Mr. Doctor?
Yeah, I'm hearing you. So I need you to write your full name in the chat, in the room chat, so I can take the attendance. Okay.
Okay.
Dr. Magid, please write my name, Rafat Al Khoury.
Rafat, okay, yeah, I'm gonna write you down. Don't worry.
But Dr. Magid believes the explanation is English and Arabic because the language money have is not excellent.
I know, and I'm gonna talk with Dr. Mukhtar about it a little bit. So I don't know. I will try to say.
Okay, no problem. But many doctors before discuss Arabic and English.
Yeah, I'm okay with that. So in case if you really didn't understand like some of the slides, you can just talk with me and I will switch to Arabic.
And slide writing in English, but in explanation only please Arabic.
Speak in Arabic, okay?
A little.
I don't know. Yeah, I will try. I will try to do that. Okay.
Oh, okay.
Abdul Jalil Muhammad Al-Maqri.
Yes, that's I am.
Yeah. And
Thank you.
Ahmed Abdul Jabbar. Muhammad Salih. I got only 7 of the names, so I think Musa Damaj is in Arabic, so I'm gonna have it. Yeah. Number 9 is me. I did like you. I didn't count myself. Okay. So yeah. So let's continue. So why are we in this class, or why we're actually having this course? This we're in class actually, or in this course actually discussing one of the, let's say, the most important or the most recent engineering disciplines, which is actually systems engineering. So we will talk about like this topic. It's like I said, it's recent. It's multidisciplinary, which means we're gonna like, let's say, touch base with some other, let's say, disciplines that you have already had, like, I think, in previous courses. So the first 3 to like 4 lectures are gonna be a little bit intense. We're gonna talk about theory more, like we're gonna introduce some concepts, definitions, and let's say or other terms related to the systems engineering and what actually you need to start this course. And then from lecture 5 on, we will have like some like more fun. We'll go like more technical. We'll have like, say, more math a little bit. We're going to talk about technical performance measures, or let's say we name them like TPM in the course. We will talk a little bit about reliability, or systems reliability, systems modeling, systems simulation, and also we will talk a little bit about systems economics, and finally we'll talk about systems management. So actually we are in this class to study systems engineering, okay? And to start that, or let's say before even starting going into any more details, let's talk a little bit about your point of view of a system. So we have this like beautiful nuclear facility here. It's for non-military use, and it's used actually mainly to generate electricity. So is this a system, and why? If I can like hear like your point of views, or maybe like even you can just type in the chat. What do you think about this facility? Is it can be considered like a system, and why? From your point of view, like, or let's say from your like general understanding. Any answers?
Again, Dr. Magid, please.
Is this system, is this a system, and why? هل هذه المنشأة تعتبر نظام، ولماذا؟ هذه منشأة نووية لتوليد الطاقة الكهربائية. هل بالإمكان اعتبارها نظام، ولماذا؟ ما هي الاعتبارات من وجهة نظرك؟
This is a system because it have more activities and more result. I don't know.
Yeah, so yeah, I have an answer here also from Ardia that she said like everything is related. Yeah, that's one answer. And for your answer is actually when you said like it has like a lot of activities. So we know that a system has like should have like a lot of activities, or let's say like several components, and they are actually interconnected with each other. Yeah. So yeah, these are actually like perfect answers, and we can consider this facility as a system. Yeah. And why? Because we say there is a lot of let's say components, there is a lot of activities running, and everything looks related. So these are already some good answers. So let's keep it up, and let's have the second one here. So we are here like the United States highway system. This is actually the let's say.
Excuse me, doctor.
Yeah.
I understood from your talking about some facilities that you are showing some pictures in the screen. Is that right?
Yeah.
Nothing is appearing in my side. Yeah. Now, okay.
Yeah.
Sorry.
These are like a nuclear facility, and we agreed this facility is a system. And why? Because we said like everything looks related. There's a lot of components, there is a lot of activities, and these activities are like interconnected with each other. So that's a perfect explanation for why we consider like anything as a system. So let's go for the second one. Here we have like, let's say, the highway system of the United States. In Arabic we can name it, let's say, خارطة الطرق السريعة في الولايات المتحدة الأمريكية. هل بالإمكان اعتبار هذه let's say نظام الملاحة هذا أو نظام الطرق عبارة عن نظام من وجهة نظرك ولماذا؟ Same thing here is like, is this a system and why?
Yes, this is a system because the damage system and planning for always.
We can say like the same thing. You mean like they are actually like connected with each other, all these roads, and they are serving they are serving
in ways.
Yeah, and they are serving a main purpose, which is actually transportation or facilitating transportation.
Yes, the same.
Yeah.
It's a system and the same. It is many activity and one related. The same answer with
one related purpose. Okay, so yeah, so that's also like a good. So we have like some understanding about how to describe a system, or actually how systems are working. So what about this one, which is actually the last one? This is like a corporate, let's say, breakdown structure for some company. Let's say we have headquarters, we have finance, we have the strategy department, or let's say the administration, the IT, and everything up to even like security department. So is this a system and why? Same question here. في الشكل اللي على الشاشة المفروض اللي يكون ظاهر عندكم، في عندنا هنا مخطط أو اللي هو التوصيف الدقيق مثلا، أو التوصيف التفصيلي للشركة، بالإضافة إلى العلاقات ما بين كل هذه الأقسام. فهل هذا يعتبر أيضا نظام ولماذا؟ For this one, I'm really looking for a certain answer. If you can like give it to me, otherwise it's okay. We just move and go to the definitions, to the formal definitions. What we can see here that there is a hierarchy. Even in the previous system, but in the previous system it was not clear. But here it's clear. There is a hierarchical structure here because it's
structure is this is a system. Okay.
Yeah, exactly. It's a system, and like.
Because
one of the yes, continue. Yes, please.
Yeah, this is a system because the plan in department and management in this company and this. Please help me, doctor.
you can speak in Arabic if you can speak in Arabic.
Yeah, but not in Arabic and English, but
it's actually a system because it has like.
يعني هو هنا نظام يعني نظام لإدارة شركة، أو إنه لمخططات لإدارة الشركة واللي تتوصف لجميع الإدارات وترابطوا مع بعض، والهيد أوفيس تعتبر يعني نظام في الشركة.
Exactly, that's actually what I'm looking for. So we have here again a system, and we have like the hierarchical structure, and that's like one of the main elements that actually, let's say, determine that actually we are dealing with a system here, because it has a hierarchical structure. It has different departments that actually are connected with each other, and they actually has to work together in order to, let's say, to make this system working, or let's say functional. Okay. So what other types of system have you, let's say, deal with or worked on, and why do you call them system? Let me give you like even like simple examples. Your cell phones, or your, let's say, smartphones, are actually systems. The laptops or the PCs that you are really like listening to me now, they're actually systems. So we're actually dealing with a lot of systems. There is like different types of systems, and even like the companies that you maybe are working with, the car that you're driving, or the bus that you're taking to work. All these are actually systems, and we're actually dealing with them like in our everyday use, in our everyday lives. So what we're gonna study here in this course is actually how to engineer those systems, how to start with those systems from scratch, and through all the stages of their life cycle up to the retirement or the disposal. That's actually the course. So we're gonna start like from zero, from the conceptual model or the conceptual design, going through the detailed designs, going through the production or the, let's say, the manufacturing or the construction, and then going to the utilization period, and then finally go to the, let's say, retirement or disposal. And that's actually what we're gonna do in this course. So we're gonna really engineer those systems, or let's say study systems engineering. So starting with the system, like there is like some formal definitions, and you can just go to the Oxford English Dictionary for a system definition. It's easily like a set of connected things. Like we said, everything looks related or connected. So it's a set of connected things or parts forming a complex whole. Or it's like a set of principles or procedures. Like you said, in the map, in the USA, let's say, national highway system, it's actually like it's principles, it's procedures, it's actually roads that actually connected people together. Okay, according to something is done, or let's say according to which something is done, or it has like a main purpose, which means like a determined objective, or the main objective is actually to drive people through like cities, or maybe like an organized scheme or method, like the company that you saw. This is the hierarchical structure of the company. That's actually a scheme.
And the system is a set of things working together as part from machines or contact network.
Exactly, connected networks, components working together, and then that's actually what's the system. What about the definition of system from point of view of systems engineering? Because that's like a general definition for a system that we were talking about. What about, let's say, the definition of like a system from the point of view of systems engineering? Here you're gonna need really a more specific definition, which you have quoted this definition from the Systems Engineering Design Principles and Models, which is actually your main textbook. I will go through all the details like at the end of the lecture. A system can be broadly defined as a set of integrated components that interact with each other and depend upon each other to achieve a complex function together. A system can be decomposed into smaller subsystems or components, and the system may be one of the components of a larger system. So that's like more specific definition, and that's actually from the point of view of systems engineering. There's also some other definitions in different textbooks. Let's have, for example, what actually are the inputs, the outputs, the constraints, and the mechanism of the system. So this is a system actually. What you are seeing here in this flow chart, or let's say in this descriptive chart, is actually a system. So a system has inputs. These inputs are actually your need, or let's say an organization needs. So these are actually your needs or requirements, which should be like an input to that system. The system could be a transportation system, a communication system, a manufacturing plant, and etc. Okay, so we have some constraints. Those constraints could be technology, economic, social, political, or maybe like sometimes environmental. As you know, these days you have to worry about environment also, because you have to be certified in order to open, let's say, a system like even like transportation, or maybe like manufacturing plants, or even like power distributions. And we have some mechanism, or let's say resource requirements. The system would actually require some resources in order to work. So these resources are human, which is actually the people, the most important part in any system. And then we have the equipment, or maybe sometimes, let's say in recent days now we have like more like softwares, and we have facilities, You have to deal with data, materials, and maintenance support. And the output in general is actually your needs. Your needs should be satisfied in order to consider that system effective. Otherwise, it's not going to be an effective system. So a system that will respond to your needs as a customer or as an organization is an effective and efficient system. Okay. So this is like a general overview of what a system should be and what are like the inputs, the outputs, the constraints, and the mechanism of the resources required for a system. And here we have like a lot of examples of several systems. Before going into more details, there's some other definitions from the INCOS, which is actually the international, let's say, national or the National Committee for Systems Engineering. They have like a handbook. It's also in your list of references. I'll show you that at the end of the lecture today. So another definition is that systems are actually a combination of interacting elements organized to achieve one or more stated purpose. So systems in general, and I'm going to say in Arabic even, مجموعة من العناصر المرتبطة فيما بعضها البعض والمنظمة أيضا بغرض الوصول أو الحصول على هدف معين أو الحصول على خدمة معينة. An integrated set of components. It can be also defined as an integrated set of components. عبارة عن مكونات متكاملة مع بعضها البعض أو جزء من نظام subsystems or assemblies عبارة عن تجميعات that accomplish a defined objective. So at the end, you should have a defined objective that all these components or subsystems or assemblies are actually working together, integrated in order to accomplish this defined objective or this purpose. These components include, there's like some examples here for components. It could be product like hardware, software, or framework, like firmware. And also we have processes, people, and information. You have techniques, facilities, and services. And also you have like other support components. We will go into details in the coming slides. So what are the characteristics of a system? So based on what we have discussed, even those pictures at the beginning, we agreed that a system should have like a main function, a meaningful purpose. And this also all coming from the definitions. كمعظم خواص أو الخواص الأساسية للنظام لابد أن يكون هناك إيش هدف معين وهدف ذو معنى. Okay. A system has a hierarchical structure, like the headquarters or the company that we saw. It should have like a hierarchical structure.
هيكل هرمي.
بالضبط. هيكل هرمي.
Yeah.
A system has interacting subsystems and components. That's also one of the characteristics. It should have like a subsystem and a component. And these subsystems and components have to be interacted with each other. A system has a life cycle. That's why I told you at the beginning, what we are doing here in systems engineering, that we are studying the whole life cycle of a product. Like in product developments, we are only studying the first part of the life cycle, which is actually the design and the production, and that's it. But here in systems engineering, we are studying the design, the production, the utilization or the beneficial period of that product, and then the disposal period, or let's say the retirement period. So the system should have like, a system should have, yeah.
Dr. Majid, please. Well, the system has a life cycle. Yes, a life cycle. What
life cycle is a time span. From your need, from the start of the conceptual model up to the disposal and the retirement of the system. So it goes through the stages.
The system only input or output will finish time?
No, these are, let's say, the input, output, and the process. This is actually like what we call a system, but the life cycle is the time span from the start of the development, let's say from the conceptual design. To have a system, you have to go through different stages, by the way. You have first to understand the needs and the requirements. That's number one. That's going to take time. So that's actually the start of the life cycle. You are first analyzing the needs and the requirements, and then go through the conceptual design, the detailed design. You have to go to the testing, and then you have to go into production or construction, and then finally you have to go to the disposal, or let's say the retirement. So this is actually the life cycle.
Please give us example in life.
We will have it. We will have it in the coming slide. Any system is an example, like your cell phone. Your cell phone, before coming to you, it goes through first like some surveys to capture the needs of the customers. Even you can take a cell phone as an example. So first I have to get your needs, what you need actually in these smartphones these days. And then I have to come up with a design. This design at the beginning or the early stage is just a conceptual design. Nothing is produced yet. And then you have to go through a detailed design, what actually the components inside that cell phone, the size of the screen, or the type of the let's say the components, or let's say the material going into the screen. Everything should be also detailed through that design process. And then you have to come up with a prototype, and then you have to test that prototype. The prototype means you can just produce like one cell phone, and then just do all the tests on that one. And then finally, you will go to the production stage or the construction stage. And after that, that cell phone gonna go to the customer, and then the customer gonna use it into like, which is actually now the functional period of the cell phone, or let's say the utilization period of the cell phone. And then that cell phone at the end will be retiring, or let's say disposal, which means then the cell phone is gonna go to the garbage, and then it has to be disposed. And in some cases, maybe companies will just collect the old cell phones and then they will just dispose of them. So that's actually the life cycle. So what we are doing here in systems engineering, that we are looking to the system like a whole, which means we are looking to the whole life cycle, not some parts of it, like maybe in product developments, we are looking, let's say, for the design stage only. And in some other, let's say, technical developments, we are looking for the operational stage or the production stage. And in, let's say, in recycling, we're looking for the disposal stage. But here in systems engineering, we're looking for the system as a whole, which means we are studying the whole life cycle in order to analyze the costs and try to minimize the cost while increasing the effectiveness of your system. So that's actually what we need to do. Is we need to do a balance between the life cycle costs. When we say life cycle costs, that's like everything from scratch to disposal, and then also we have to increase the effectiveness while making that cost like life cycle cost as a minimum. And finally, the system has a reliability.
Yes.
There is no system with 100% reliability. We know that. But at least we need to make our system reliable. It has to have, let's say, the optimal reliability or the maximum reliability. And also we have to worry about the problems that are going to happen. And when you are designing your system, you are dealing with your system, you have to take Murphy's law as, let's say, as something that you really need to carry out with you through all the stages of, let's say, designing the system, that anything that can go wrong will go wrong at some point. So there will be like some failures, some errors. And
Mr. Dr. Magid, please, the system is easy to maintenance and upgrade improvement.
That's one of the sides of the reliability. We have a reliable system. That means the system should be maintainable and should be, let's say, reliable, which means it should be, let's say, it has to work or has to function as described in the same, let's say, operation characteristic that you're gonna, let's say, operation considerations, and it has to do the work that you describe that system can do, considering the let's say, the work environment. So it's actually, there is no 100% system. Let's say there is no 100% reliability, but at least we need to. The system has a reliability, and that reliability should be maximized. Also, you should work with the maximum reliability when you design your system. You have to take that into consideration. Also, you have to take that. You need to make room for maintainability, which means your system should be like reliable and can be maintained and come back to the best operational level. So now we agreed that the elements of a system should be like subsystems, components. Systems has attributes, like we said, that attributes that describe those components.
Doctor.
Yeah.
My question is about the characteristic of a system.
Yeah.
Every system must have these all characteristics.
Yeah, most systems should be in that way. These actually like the main characteristics: a main function, a meaningful purpose, a hierarchical structure, subsystems and components that are interacting, a life cycle, and a reliability. That's the main characteristics.
If one of these characteristics has been moved or not found, so we cannot say this is a system.
Yeah, based on let's say our consideration as systems, like systems engineering, we can say that either your system is that's actually not a system, or your system is missing something really important, like reliability. You cannot have a system without a reliability. Your system should be reliable, and then there's like maintenance actions and maintenance activities, and all this stuff related to making your system reliable. So these are actually the main characteristics. Without one of these, there is no system. Okay.
Okay, thank you very much.
You're welcome. So let's go now. Now we agreed, okay? We agreed that we have subsystems, we have components, we have attributes that the actual attributes actually describing your subsystems or components. And also we have relationships, okay? So systems and components, we agree that these are the fundamental constructs or functional units of system. Attributes, these are actually what's actually define and specify the system components, and they mostly called design dependent parameters, or DDP, okay? Systems, components, and systems like interacted, or sorry, components and subsystems are interacting with each other to regulate system behavior, and they should have like different relationships. And these relationships are essential for successfully translating the system requirements into component attributes, providing system rational, and also providing traceability for system design activities. So these actually, let's say, what system should look like, and what are the major elements of a system. Now we agreed that we have subcomponents, we have subsystems, components, we have attributes, and we have relations. So what are actually the major elements of a system? You can come up with a lot of elements, and these actually are the, let's say, the most complete list I found in your textbooks, which is actually going from operating personnel to maintenance personnel to test support equipment and maintenance software, all maintenance related or operational related, let's say, elements. And then like anything you can find like away from this chart, you can just add it into the, let's say, under the other elements category. Okay, so this is actually the system and main, let's say, major elements. And this is actually, like I told you, is the most complete list I found in the text.
Dr. Magid,
yeah.
This is example the major element from a system. All items, this a system, or one only item operation equipment, the system only.
No, these are major elements.
Yeah.
Okay, they could be maintenance related, or it could be operational related, and could be like other elements, because that's actually what we are talking about. The major elements are going to be either operational related or maintenance related. You may find like even if I took this picture out and ask you for examples, you may give me even like some other elements that's not in this chart, but still this is like, I think, the most complete list I found in the textbook. So these are like examples of some of the major elements of a system. You just go through them and make yourself familiar. So just in case, if you go through your, let's say, project, you will know at least what are the major elements when you choose a system, and you will focus on those elements when you are doing when you are applying the concepts of this course into your, let's say, project. If we agree to have projects, we're going to discuss that at the end of the lecture. Don't worry about it now, okay? Classification of systems. So actually, these classifications coming from like most of the textbooks that I will actually post to you, or let's say give you. And we have natural systems versus man-made systems. Can you give me some example of a natural system? Just give me a system, a natural system.
The example.
نظام من الطبيعة. Yeah, an example.
النظام الشمسي.
Exactly. Solar
الشمسي.
System. Yeah. And what about the man-made systems? The thing that you are talking to me now.
Traffic system.
Your computer, your cell phone, like it's a man-made system. Any system that made by man or made by human is actually a man-made system, and all other actually, if human are not really, let's say, they did not participate in making that system, that's a natural, or let's say, natural-based system. Yeah. So for natural system, we have the planet, we have the oceans, we have the lakes. And for man-made system, we have computers, automobiles, and we have tools and equipment. And also systems can be classified as static and dynamic. And from point of view of systems engineering, there is no static system. When we see systems from like a whole, like I told you, there's no, from point of view of systems engineering, there's no static systems. We are always assuming that systems are dynamic and they are, let's say, exchanging with the environment or affecting the environment. And that's actually the reason they are building a system. It has to serve a purpose, or let's say, have a main objective, and that objective will affect the environment. So let's say from the point of view of systems engineering, there's no static system. All systems are dynamic, but you can still find some examples if we look at those from the physical point of view. So from physics or thermodynamics even. So for static systems, or maybe when it comes to studying the bridge building and highways, we don't want these stuff to be dynamic. So when we are studying a production facility, we're going to consider the building as a static system, because we don't want to worry about the building. We will worry about the stuff that's going beneath, or let's say under the roof of that building, which is the operation of the maintenance.
Please, Dr. Magid, under the building or under the bridge, only dynamic system?
All systems are dynamic. From point of view of systems engineering, all systems are dynamic, but there is some systems that can be considered static, like bridge, like a building. The building is a system, by the way, and that building is affecting the environment. But sometimes, just to study what's inside that building, sometimes we consider that building as a static system.
Yeah.
Yes, we say that it's not affecting the environment, which is already there, and it's like a structure. So most structures are considered as static systems when it comes to systems engineering. Like a highway, it's already there, it's done. Like a bridge, it's also already there, it's done. So I'm gonna study all other activities, but I'm gonna leave the structure alone as a static system, just to make it easy to study your system, okay? Because the bridge, the building, and the highway are actually like it's like a subsystem inside a bigger system. So to make it easy, we just assume those systems static, so we can really study the rest of the, or let's say the rest of the components of the subsystems that your system has, okay? When it comes to dynamic systems, production facilities are dynamic, even service centers are dynamic. And you can imagine a service center, it's like highly dynamic. Every minute, every second, you may have like a customer come in, or maybe like a paper processed, or it's crazy and it's highly dynamic. Production facilities are the same thing. Everyone is working under a production facility. Everything, even if humans are in a rest, machines are working, or maybe like managers are working. So these are like some examples of a dynamic system. And when it comes to, let's say, classifying the systems from point of view of being physical or conceptual, there's a lot of examples, but the most important one, Muhammad Al-Khatib raised the hand. Yeah, you can either talk or chat.
Just
the minute.
I want to say for everybody, could you please mute your mic after your interference, because it will increase.
Please do that.
Yeah.
Otherwise, I will mute you from here. Like whenever you finish talking, just mute so the other students will not hear noise in the background. Okay. So when it comes to conceptual systems, simulation models are always conceptual systems. Like an example could be a simulation model for a factory, or let's say a blueprint is a conceptual system, a blueprint for machine assembly, and even like information processing models for human cognition and perceptions can be considered as conceptual models. Physical models are all other models that do not fall in the category of conceptual models, are all physical systems, okay? So any system that consists of objects that can be seen, touched and felt, these are physical systems. And when it comes to open systems versus closed systems, again, like we talk about static and dynamic, we always consider systems to be open, and from point of view of systems engineering, as these systems are actually interacting with the environment and actually built to serve, let's say, determined objective, serve the need of a customer or an organization. So they are actually interacting with the environment. So we cannot consider them a closed system. But when it comes to like the examples are listed here, like a sealed container of water or gas, that could be considered a closed system because it does nothing to the environment, or it's actually not interacting with the actual, let's say, the environment or the surroundings around it. Okay.
That tower, doctor, that tower is a dynamic system or a static system?
Which one?
زائد تاور، برج زايد من ده اللي اسمه ابو.
If you're gonna deal with the structure, it's like the tower, or let's say the building in general, it's a dynamic system, because
اوكي
it's not just a facility there. It has like a lot of stuff in it. But if you're gonna deal with the structure itself, or you're gonna study the whole building or the whole tower, so the structure is static, which is the building, but everything inside that building is dynamic.
Yeah.
How they manage the system, the maintenance, how they manage the operations, how they manage safety, how they manage security.
Dynamic system here.
Yeah, it's a dynamic system. Yeah, but you're gonna remove the building from the equation just to make it easy. The building itself gonna be removed from the equation, but all the processes inside the building, or the components or the subsystems, they should be considered as dynamic system and should be analyzed.
Okay.
Here we have a digital photography. I'm gonna really need your opinion, or let's say your let's say what's actually the feeling that comes to your mind, or the ideas that come to your mind as soon as you see this picture. It's a digital photography, let's say, system. We have the cams, and then we have the PCs, and then we have the printers.
دكتور
The operations that's going around. So just briefly describe it. The first thing coming to your mind. ما هو الشيء الذي تفكر به بمجرد رؤيتك لهذه الصورة؟
دكتور can you speak English Arabic please?
Me or you? You're gonna answer in Arabic, or you want me to speak in Arabic?
يعني بعض
Yeah.
حتى رؤوس أقلام دكتور، حتى يعني بالبداية، وبعدين ممكن نتكلم على العربي.
For some of the concepts here, they are actually clear. You can even like read them. And unless you want, like I told you, just stop me at any point in time. Just stop me and ask me to explain stuff in Arabic if you want me to do that.
يا شباب، اي واحد ما افتهملوش مع الدكتور يوقفه في اي نقطة ويسأله بالعربي عادي.
Exactly.
احنا نتكلم عفوا دكتور، بس بعض الملاحظات انه النقاط الرئيسية فقط يكون عادي بالعربي، وما نريد نقاطعك، بس احنا ما نريد نقاطعك، نريد نسمعك على طول.
اوكي.
اذا في شوية بالعربي شوية بالانجليزي.
ما أنا كيف نسمع ما نفهمش. في ناس يكتبوا بالمجموعة يا دكتور ما فهمناش.
With the group.
Yes.
ايوه في الجروب انه ما في. ايوه.
Okay, Dr. Majid, please Arabic and يعني half and half.
Half and half. Okay. I'll do my best. Do you want me to go back or just continue?
اوكي.
عفوا بس مداخلة بسيطة. أنا يعني أشوف إنه إذا في حد يشتكي عنده مداخلة ولا شيء يرفع يده بس، لأنه الدكتور يتكلم عن شيء وتضيع معلومة بمداخلة شخص آخر، فهمت؟ فيفضل يعني لو كل شخص يرفع يده وقت المداخلة، إذا أعطاه الدكتور الإذن فيطلع للمايك، وبعد ما نخلص المداخلة نقفل المايك عشان الداتا ما تكونش أكثر نفقد الاتصال ولا شيء.
اوكي شكرا.
Thank you Mr. محمود الخطاب. Thank you.
Yes, okay. That's a good suggestion. We should work from there, okay? وهذا كان اقتراحا جيدا، ولا بد أن نعمل من هناك. شكرا محمد. طيب الآن تحبوا أرجع ورا وأبدأ من جديد ولا نكمل؟
ممكن تعمل لنا ملخص سريع يا دكتور، ونبدأ من هذه الصفحة
لو سمحت. احنا وصلنا إذا تفضل.
طيب بالبداية هنا تكلمنا عن الأنظمة وإيش وجهة نظرك، أو مثلا لو شفت صورة معينة كيف تقدر تحكم عليها إنه هذا نظام أو لا. واتفقنا إنه عشان نحكم على أي مثلا مكون أو أي شيء موجود أمامنا على إنه نظام أو لا، لازم يكون في إيش؟ لازم يكون في مكونات، لازم يكون في عناصر. هذه المكونات والعناصر لازم تكون مرتبطة في بعضها البعض وتؤدي وظيفة معينة. تمام؟ وجبنا شوية أمثلة مثلا زي هذا مثلا اللي هو نظام توليد الطاقة، النظام النووي لتوليد الطاقة عبارة عن نظام. نظام الطرق السريعة عبارة عن نظام لأنها متصلة ببعضها البعض وتخدم هدف معين. حتى بالنسبة مثلا للشركات أو بالنسبة للسوفت ويرز اللي ترتب الشركات، هي عندها مثلا اللي هو الجزء اللي هو الهيراريكال ستراكشر هذا اللي هنا، ويعتبر ايضا نظام لانه في توصيف معين وفي اقسام، والاقسام هذه مرتبطه في بعضها وتؤدي وظيفه معينه تخدم الوظيفه الاسمى اللي هي ايش؟ اللي هي مثلا ما تقدمه الشركه للزبائن. تمام؟ فكان هذا بشكل عام انه مثلا ايش تعرف عن النظام وانواع الانظمه، وايش الانظمه اللي ممكن انت احتكيت فيها وليش تسميها انظمه. تمام؟ اتفقنا انه حتى بالنسبه للتلفون، التلفون عباره عن نظام اللي موجود في يدك،
تمام.
وهذا النظام له مكونات واشياء تتعامل مع بعضها البعض بشكل متكامل لتقوم بمهمه معينه. هذا هو النظام، هذا الزبده. تمام؟ وبعدين دخلنا في ايش ممكن يكون في النظام، ايش الانبوت، ايش الاوتبوت، المدخلات، المخرجات، القيود، المصادر والمتطلبات، وانواع الانظمه. تكلمنا عن تعريفات الانظمه من وجهه نظر عامه ومن وجهه نظر السيستمز انجينيرنج. تمام؟ هذه مجرد تعريفات، هذه خواص للنظام. في اشياء ما اقدرش اترجمها للعربي للاسف الشديد فلازم تاخذوها زي ما هي كده كمصطلحات.
ما في مشكله
انجليزيه. تمام؟ يعني مثلا بالنسبه اللي هو الريلايبيليتي، اللي هو المعوليه او الموثوقيه زي ما تسموها انتم. تمام؟ رجعنا شباب، اللي فاتح المايك لازم يقفل عشان ما يحصلش ضجه او ازعاج بالخلفيه للشباب اللي يسمعوا المحاضره. يا فاتح المايك لازم يقفله بعد ما يخلص المداخله تبعه. اوكي؟ طيب، واتفقنا بعد خواص النظام، تكلمنا انه الريلايبيليتي مهمه، تكلمنا انه اللايف سايكل مهمه، بندخل بالتفاصيل هذه لاحقا ان شاء الله. تكلمنا انه النظام فيه عباره عن انظمه جزئيه ومكونات، عباره عن ستراكشر هرمي او مخطط هرمي. تمام؟ النظام تبعك قد يكون جزء من نظام كبير وقد يكون العكس. تمام؟ واتفقنا انه النظام لازم يكون له هدف. تكلمنا على اللي هو العناصر النظام. تمام؟ وايش الاتريبيوت مثلا وايش الكلام هذا. وبعدين تكلمنا عن الجزئيات الخاصه بالعناصر الاساسيه. الى هنا كان عندنا اللي هو الانظمه مثلا الطبيعيه اللي جايه من الطبيعه، والانظمه اللي من صنع الانسان. حطينا شويه امثله. الانظمه الثابته الغير متغيره والانظمه المتغيره، حطينا امثله. الانظمه اللي هي عباره عن ايش؟ اللي عباره عن محتوى غير ملموس، والانظمه اللي عباره عن محتوى ملموس او شيء ملموس ممكن انت تحس فيه. تمام؟ يعني هذا ممكن كيف تقسم الانظمه هذه؟ عده، او حسب الكتب الموجوده، هذه عده تصنيفات للانظمه. قد تحط مثلا انت كنظام طبيعي نظام من صنع الانسان، نظام ثابت، نظام متغير، نظام عباره عن محتوى او مكنون، ونظام عباره عن ايش؟ عن شيء محسوس او ملموس، زي اتفقنا اللي هو المحاكاه مع النظام الفعلي او مع المصنع الفعلي اللي سويت له محاكاه. هذاك عباره عن conceptual system او اللي هو محتوى، نظام عباره فقط عن محتوى غير محسوس. والفيزيكال سيستم اللي هو المصنع نفسه عباره عن شيء محسوس. ممكن ايضا تصنف الانظمه على اوبن اند كلوزد، وهذا جاي بالغالب من الثيرموداينامكس او من الفيزياء او حتى من الكنترول سيستمز، عباره عن اوبن اند كلوزد. بس اتفقنا انه في السيستمز انجينيرنج ما فيش عندنا حاجه اسمها اوبن اند كلوزد. معظم الانظمه عباره عن اوبن سيستمز، لان لابد ان تحتك بالبيئه لان تخدم زبون معين، تخدم شركه معينه. تمام؟ وكلوزد اتفقنا مثلا انه الانظمه قليله جدا اللي تعتبر كلوز، لكن اعطينا شويه امثله عشان بس اعطيكم فكره انه ايش الامثله اللي ما تحتاجش في ايش في الانفايرمنت او في الاشياء في الطبيعه او فيما يحصل حوالينها بشكل عام، زي الكونتينرات المغلقه سواء للماء او الغاز او الاشياء. الان بالنسبه للصوره هذه، ايش اول شيء يخطر في بالك مجرد ما تشوف الصوره هذه؟ what's the first thing coming to your mind when you see this picture? محمد الخطيب raised his hand so he can talk.
Conceptual system.
It's not conceptual because we can feel it. It's there. You can feel the camera, you can feel the printer, these are like actual systems. It's a digital photography, so it's there, it's physical. What I'm talking, what you are seeing here, is it a single system? Is it like multiple systems connected to each other? What's the first thing that coming to your mind? ايش اول شيء يخطر في بالك؟ هل هذا عباره عن نظام واحد فقط ولا عباره عن اكثر من نظام في نفس الوقت، وكل نظام هو عباره عن نظام معقد في حد ذاته؟ ايش اللي ممكن يخطر في بالك مجرد مثلا ما تشوف الصوره هذه؟ Yes, you can talk. Rafat, you can talk.
مجموعة أنظمة متداخلة. أعتقد مجموعة من الأنظمة تشتغل مع بعضها لهدف معين.
شكرا بلال. رأفت؟
يعني هي بالاخير عده انظمه، كالكمبيوتر مثلا مع بعض مشبوك، معك الطابعه لنظامي خاص، معك الفلاش نظامي خاص، بشكل عام كذا يعني عده انظمه كل واحد له نظامه الخاص بس مترابط فيما بعضهم البعض
لغرض معين، هو انه مثلا انك تصور ومثلا وتحصل على صوره ايش مطبوعه بالضبط.
ايوه.
محمد الخطيب if you want to add something. Thank you رأفت. Thank you رأفت.
بس يا دكتور البرمجيات اللي موجودة في البي سي هذا مش محسوسة ولا نقدر نشوفها أساسا.
اللي هو هل إنه هذا نظام أو لا، ما يشيش يتكلم عن البرمجيات الداخلية بالأخير هو كشكل عام.
حتى بالنسبة للبرمجيات بغض النظر عن تصنيف النظام هل هو conceptual أو غير ذلك، أنا قصدي إنه إيش اللي يخطر في بالك أنت لما تشوف هنا عبارة عن calibration between different systems. الآن في different systems أو أنظمة مختلفة تم إيصالها مع بعض لغرض الحصول على إيش؟ على printed photocopy or let's say digital photography. إنك بالإمكان إنك تطبع الصورة هذه. فتحتاج كاميرا، الكاميرا عبارة عن سيستم بحد ذاته، تحتاج إلى إنك كيف تربط الكاميرا بالكمبيوتر أو كيف تنقل الصور للكمبيوتر. لازم تشوف لك نظام وسيط يقوم بنقل الصورة هذه للكمبيوتر. الكمبيوتر نفسه عبارة عن نظام. بعدين من الكمبيوتر إلى الطابعة لازم نظام وسيط أو كيبل زي ما هو نفس الصورة، وبعدين الطابعة الحالة هذه نظام مختلف تماما. ففي الغالب الحالة بوصل أنا من الصورة هذه إنه حكاية إنه يكون عندك مثلا نظام قد ما تكونش المشكله كده انه بس انه نظام وانظمه جزئيه وكومبوننتس، قد يكون عندك اللي هو نسميه احنا في السيستمز يا جماعه سيستم اوف سيستم. اوكي، اللي هو سيستمز اوف سيستمز، يعني انظمه متداخله مع انظمه معينه، وهذه هي الاكثر تعقيدا. like it's more complicated. Okay, and mostly like never ending, like it's always there. So it's like system of systems. This is like one of the term or the concepts I want to introduce you today to, which is like system of systems. يعني عبارة عن نظام من أنظمة زي ما شفنا في الصورة هنا. هيبقى هذا الآن عبارة عن إيش؟ ديجيتال فوتوغرافي، هذا نظام. لكن في داخل هذا النظام عندي الكاميرا، عندي اللي هو الأجهزة اللي تشبكني في الكمبيوتر، عندي الكمبيوتر، عندي الأجهزة اللي تشبكني في الطابعة، وعندي الطابعة برضه. فعبارة عن يعني الأنظمة اللي زي كذا كثيرة، لكن أنا حاولت أجيب واحد سهل جدا عشان الكل إيش؟ عشان توصل الفكره للجميع. So I can really like deliver the idea in a most, let's say, perfect way. So we get that system of systems are large scale interdisciplinary problems involving multiple heterogeneous and distributed systems. System of systems او النظام المكون من عده انظمه عباره عن نظام كبير جدا من انظمه متداخله مختلفه تماما عن بعضها. زي ما شفنا احنا عندي حاسوب، عندي كاميرا، عندي طابعه، انظمه مختلفه تماما عن بعضها البعض، ومشاكلها ايضا مختلفه، وفيها عباره عن يعني انظمه عديده، عباره عن انظمه عديده. Okay, so let's talk about more details. So system elements operate independently. Okay, system elements have different life cycles. The initial requirements are likely to be ambiguous. It's not clear or unclear. Complexity is a major issue when it comes to studying such systems. Complexity is one of the major issues. Management can overshadow engineering here. When it comes to system of systems, management can have the upper hand when it comes to let's say to analyze those systems or even to operate such systems. Fuzzy boundaries cause confusion. And finally, like system of systems engineering is never finished. I think Muhammad raised his hand. You can talk.
Yes, Doctor, thank you. The initial requirements are likely to be ambiguous. ايش المقصود بالضبط؟ يعني ممكن تعطي لنا مثال؟
المتطلبات الاساسيه قد تكون غير واضحه. مثلا لما يكون عندك system of systems، المتطلبات الاساسيه قد تكون غير واضحه. سواء من النيدز اللي جايه من الاورجنايزيشن او حتى من الزبون، اوكي؟ او المتطلبات اللي يحتاجها النظام، لانه عندي اكثر من نظام. فالريكوايرمنتس بتصير كثيره كمبدئيا، بس بعدين لما تدخل في التصميم او التكوين او حتى لما تدخل في مرحله اللي هي الاوبريشنال، بعدين تبدا ان تتضح المتطلبات واحده واحده. يعني انت لو رجعنا للصوره حتى اللي هنا اللي معانا، if we go back to the picture here, I think all of us when we started to print like our first something, sometimes you're gonna feel there's something missing here. Maybe you don't have the adapter, you don't have the card reader, you know what I mean? Maybe you don't have the cable, or maybe your printer can be connected Wi-Fi or not. So you don't know actually the initial requirements. You can really print that photo. So sometimes I still remember even myself when I first tried to print something like from a camera or from another device, not from the desktop directly. There's something missing because the initial requirements are not clear because it's a complex or complicated system. Okay, I hope that was clear. Okay, so yeah, I think we have finished, let's say, our first part of the agenda, which is actually the first part was the welcome and the introduction. You didn't introduce yourself, you just give me your name. So I'm gonna call it even, but we're gonna talk next time. So what are systems? We discussed that, and now we know what are systems, and we have even come up with the concept of system of systems. And now we're gonna talk about systems engineering. What is systems engineering? Can you please give me any idea you have about systems engineering, or maybe you have read there and there in one of the textbooks, or maybe in websites? What is systems engineering?
فسيستم انجينيرنج يعني يعني تطبيق يعني العلوم الرياضيه يعني والطبيعه المكتسبه عن طريق الدراسه وغيره كذا يعني التطبيق الرياضي كانه ما بين الفيزياء والرياضيات.
Okay, that's an acceptable answer, but it's not complete. So let's say Muhammad Al Khatib, I think he raised his hand. Thank you, Rafat.
Yes, I think like what Rafat said, just to apply the methods for design the systems.
Okay, it's an acceptable answer, but it's missing the main component. The main component of the definition is missing, but still good answers. Thank you, Rafat, and thank you, Muhammad. So let's go through let's say the official definitions. Okay, we have different definitions coming from different organizations and textbooks. So let's start with this one. Systems engineering is the profession in which a knowledge of the mathematical and natural science, as you have both said, gained by study, experience, and practice, is applied with judgment to develop ways to utilize economically the materials and forces of nature for the benefit of mankind. So in general أو بشكل عام زي ما تكلموا زملائكم إنه عبارة عن مهنة نقوم فيها باستغلال اللي هو المعرفة بالرياضيات والعلوم الطبيعية والتي أساسا اكتسبناها نحن من الدراسة ومن التطبيق ومن الخبرة لكي نطبق كل هذا على إيش؟ على شيء معين ممكن يفيد البشرية. الشيء المعين هذا قد يدخل فيه اقتصاديات، يدخل فيه مواد، ويدخل فيه أشياء أخرى. المهم في الأخير أن تخدم شيء معين يهم الإنسان أو البشرية. هذا التعريف عام. This is a very general definition coming from the American Board for Engineering and Technology from ABET. Okay, and this is actually for engineering, not for systems engineering. This is for engineering. So before going into systems engineering, we defined engineering. Now let's go a little bit into more details. It is the application of what, engineering in general, is the application of what we discover from science and man-made systems. Systems engineering similarly applies the knowledge, like we discussed, the theories, the models, and the methods of system sciences based on the philosophy of systems thinking to guide in designing man-made systems. So it's the same thing. It's still engineering. It's a profession. It's a discipline. It's a multidisciplinary field. So we are doing the same thing that we're doing with engineering, but let's go into more specific definition. Okay, systems engineering is a discipline that concentrates on the design and application of the whole system as distinct from the parts. It involves looking at a problem and its entirety, taking into account all the facets and all the variables and relating the social to the technical aspects. So that's a little bit more difficult definition. I don't like it, but I'm gonna take you to the best one just in the comment slide. Let's go to through another definition. Systems engineering is like an iterative process. So I want you to focus on the colored, let's say, words. doing those definitions. That's are the most important part of these definitions, and then we're going to come up with an official definition in the next slide. So systems engineering is an iterative process of top-down synthesis, development, and operation of a real-world system that satisfies in a near optimal manner the full range of requirements for the system. So بشكل عام عشان اللي حابين نتكلم في بالعربي، اللي هو هندسة الأنظمة تهتم بالنظام بشكل عام، نظام بشكل كامل، تمام، بكل المكونات. يعني بننظر من النظام من فوق خالص ونشوف النظام بشكل كامل. واللي كان ناقص زي ما تكلم رأفت ومحمد انه كنت حابب انهم يذكروا جزئيه انه اللايف سايكل. هذه شيء مهم جدا، لانه احنا لما نتكلم عن systems engineering we are talking about the whole life cycle of the system. لانه في بعض الاجزاء الاخرى زي ما اتفقنا اللي هو البروجكت ديفلوبمنت او اللي هو البروجكت ديزاين والكلام هذا، نهتم فقط بجزء معين من حياه النظام هذا ونترك الجزء الباقي. لكن هنا في systems engineering we are dealing or let's say we are focusing on the whole system life cycle.
عفوا بليز دكتور دكتور مجيد، الصوت الاخير ضاع علينا، ممكن كذا اعاده؟
اوكي.
الصوت كان لما تتكلم ما وضحش عندنا، ممكن تعيده كذا شويه هذه النقطه؟
حاضر. اللي تكلمنا فيه انه في السيستمز انجينيرنج زي ما تفضلوا محمد ورافت قام يعني يعطونا مثلا شويه تعريفات لاستخدام مثلا الرياضيات والمواد العلوم الطبيعيه، هذا اللي نعرفه احنا عن الانجينيرنج بشكل عام اللي كان في الديفينيشن هذا اللي جاي من الابت فور انجينيرنج اند تكنولوجي، تمام. لكن في السيستمز انجينيرنج احنا نشوف النظام ككل، نشوف حياه النظام بشكل كامل. مثلا في زي ما اتفقنا في البرودكت ديزاين، في البرودكت ديفلوبمنت، في الاشياء هذه ناخذ جزء معين فقط من حياه النظام هذا ونسيب الجزء الباقي. لكن في systems engineering we are dealing with the whole system and we are studying the whole life cycle of the system. هذا كان الجزء الوحيد اللي كان ضايع من التعريف اللي جابه الشباب، اوكي. والجزء الاخر انه هو عباره عن iterative process. It's an iterative process of top-down synthesis. واهم نقطه انك تجي من فوق الى تحت، مش العكس. في بعض الاشياء ممكن تمشي كعكس، لكن فيها فقط تجي من فوق الى تحت وبعدين يعطيك اللي هي الفيدباكس. ليش؟ لان احنا نتكلم عن ايش؟ عن لايف سايكل. Life cycle cannot be reversed. It's just going from top to down, or from zero to infinity, or from zero to t, like a point in time when the system dies or retired or disposed. Okay. التعريف الأشمل اللي هو من واحد من الكتب حط لكم من السورس تحت. هو systems engineering is like interdisciplinary approach and means to enable the realization of successful systems. It focuses on defining customer needs. شوف التدريج تبع التعريف الآن، okay? It focuses on defining customer needs and require functionality early in the development cycle, documenting requirements, then proceeding with designing or design synthesis and system validation while considering the complete problem. Operation, performance, test, manufacturing, cost and schedule, training and let's say support and disposal. Okay, so we are going from the needs up to the disposal, the whole life cycle. Okay, systems engineering considers both the business and the technical needs of all customers with the goal of providing a quality product that meets the user needs. Okay, فهذا بشكل عام التعريف اللي اتفقنا عليه، انه هو عباره عن مجال متعدد تدخل فيه اكثر من تخصص في نفس الوقت. يعني الاهتمام فيه انه نحصل على successful systems او انظمه ناجحه. نركز من البدايه خالص من تعريف المتطلبات والاحتياجات للزبون او للمنظمه او للشركه او ما الى ذلك، وندخل بعدين خطوه خطوه اللي هو بالفانكشناليتي او خلينا نقول الوظائف، التوثيق والديزاين وكله، الين نوصل الى اخر جزئيه اللي هي عباره عن ايش؟ عن الديسبوزل او التخلص من السيستم هذا بعد ما ينتهي عمره الافتراضي. اوكي، وبهذا الشكل هذا هو السيستمز بشكل عام. يعني اللي حابب نوصل لكم انه الفكره هنا لازم تفكيرنا يختلف شويه، لان احنا هنا الان نتكلم عن ايش؟ عن اللايف سايكل، او نتكلم عن دوره الحياه كامله للنظام هذا، مش اجزاء معينه منه. اخذنا مواد كثيره وانا متاكد انكم اخذتم مواد كثيره سواء في البكالوريوس او في الماجستير، نهتم باجزاء معينه. مثلا في الاوبريشنز ريسيرش كان همنا نسوي اوبتمايزيشن للعمليه نفسها، ما لناش دخل بالتصميم، ما لناش دخل بالديسبوزل، ما لناش دخل مثلا حتى بعض النماذج قد تكون للصيانه، بعض النماذج قد تكون للانتاج، في المحاكاه نفس الشيء.
دكتور مجيد يا بس what is the different about system engineering and design product design؟
البرودكت ديزاين يوصل الين الانتاج وخلاص. بالضبط يوقف. لكن في السيستمز انجينيرنج بعد الانتاج في عندي اللي هي اللي هو فتره العمل للمنتج هذا، وبعدين التخلص من المنتج. فتره العمل تشمل اللي هي الصيانه والريلايبيليتي والاشياء هذه، المنتج شغال مش شغال،
يعني بعد تجهيز المنتج.
اي بعد تجهيز النظام مش المنتج، لان البرودكت ديزاين السيستم قد يكون برودكت بنفس الوقت على فكره. فانت في الديزاين او في البرودكت ديزاين وفي البرودكت ديفلوبمنت نوصل على البرودكشن وخلاص انتهت المهمه. الاشياء الباقيه ما ندخلش فيها. لكن هنا في السيستمز انجينيرنج انت تاخذ السيستم من بدايه النيدز قبل التصميم، حتى من النيدز الين توصل على الديسبوزل. الديسبوزل معناته انه الاتلاف اللي هو التخلص من النظام هذا بعد ما انتهى عمره الافتراضي. يعني انت لازم وانت تسوي النظام هذا لازم يكون تفكيرك اشمل شويه، لازم يكون تفكيرك اشمل، لازم تاخذ الصوره بشكل كامل حتى انك تسوي حلول. انه مثلا كيف نسوي ديسبوزل للسيستم هذا، كيف الزبائن مثلا يرجعوا لنا النظام هذا، او كيف نسوي له مثلا ريسايكلينج. يعني مشاكل كثيره لازم تمر فيها. عشان كده احنا اتفقنا انه انتر ديسيبلينري، معناته انه في اشياء كثيره بتدخل. انا بحاول قدر الامكان اخذكم على الاشياء اللي هي في الكورس هذا، الاشياء اللي هي مثلا اخذتوها من قبل كمهندسين صناعيين وحتى كمهندسين ثاني من ميكانيك اذا عندنا شباب من ميكانيك، اللي هي مثلا الريلايبيليتي اخذناها تقريبا، السيموليشن اخذناها، الماثماتيكال موديلنج اخذناها، حتى الايكونومكس اخذناها. فهذه اشياء انت بتحتاجها عشان مثلا تحسب كم بيكلفنا المنتج، كيف اسوي المنتج صيانه، كيف ارفع الريلايبيليتي حق المنتج هذا، كيف حتى نسوي مانجمنت للمنتج هذا، كيف السيستمز مانجمنت. اوكي، يعني نحاول نغطي كل الاشياء اللي ممكن نحتاجها زي ما اتفقنا من النيدز الين نوصل على مين، على الديسبوزل. هذا هو اللي بيكون موضوعنا. طبعا اول 3 محاضرات بتكون ثقيله شوي لانه بتكون نفس النظام هذا، يعني شويه رسمات على شويه فيجرز على شويه فلو تشارتس على شويه كلام وتعريفات، ونناقش شويه المصطلحات عشان بس ناخذ الصوره العامه. وبعدين لما ندخل بالرياضيات هناك بتبدا الاشياء تكون اكثر وضوحا، وخلينا نقول بتكون شويه ممتعه يعني. اوكي، فخليكم معي واصبروا شويه لين نخلص من تعريف الاشياء الاساسيه باذن الله. اول 3 محاضرات المحاضره الرابعه، وبعدين بنبدا بمراجعه للبروبابيليتي والستاتستكس والكلام هذا، عشان ندخل بعدين مباشره باللي هي نسميها احنا اساسا ليش الاشياء هذه اللي تكلمنا عليها بندخل فيها اللي هي الاشياء الرياضيه. عشان احنا في الاول والاخير لما نسوي سيستم لازم ندرس اللي نسميها احنا اللي هي التي بي ام اللي هو التكنيكال بيرفورمانس ميجرز. فلما ندخل على التكنيكال بيرفورمانس اللي هو البرفورمانس ميجرز هنا معناته انه كيف النظام تبعك بيشتغل. فلازم انت تصمم النظام تتاكد انه الريلايبيليتي تمام، تتاكد انه الاوبجيكتيف انت مسوي الاوبتيمال اوبجيكتيف. عشان تسوي الاوبتيمال اوبجيكتيف انت عارف انك محتاج تسوي ايش، تحتاج مثلا تسوي ماثماتيكال موديل وتحل الماثماتيكال. رجاء اللي فاتح المايك يقفل. تمام، مثلا انا كيف اتاكد انه عندي الاوبتيمال اوبجيكتيف والفانكشن اللي السيستم هذا يخدمها. فلازم قد احتاج اسوي مثلا ماثماتيكال موديلز، او اذا النظام تبعي صعب شويه قد احتاج اسوي مثلا سيموليشن وادرس النظام هذا وكيف النظام هذا بيشتغل مثلا في الظروف المعينه وفي الظروف اللي هو صمم لها، وايش مثلا العيوب اللي بتطلع وكيف بنعالجها والاشياء هذه، وكيف ارفع الريلايبيليتي. فبندخل مثلا في موضوع الريلايبيليتي، بندخل في موضوع اللي هي السيموليشن، ندخل في موضوع اللي هي حتى الايكونومكس، مثلا كيف نحسب التكاليف والاشياء هذه، كيف نسوي البريك ايفن بوينت عشان نتاكد من النظام يعني بيكون في الاول والاخير فيه منه ربح او مش مكلف، او يعني ما يكونش فقط كلفه على الفاضي. وبعدين في الاخير كيف نسوي مانجمنت لكل الاشياء هذه مع بعض. احنا نتكلم على جزئيات كثيره جدا في اللايف سايكل تبع السيستم هذا، كيف بتسوي لها مانجمنت انت بعدين. هذه الاشياء كلها لازم تكون محدده. حتى انت لما تاخذ المشروع يعني لازم تبدا بهذا الشكل، تبدا مثلا تختار نظام معين. اذا اتفقنا مثلا نمشي في مشروع او في ميد تيرم، تختار نظام معين. مثلا انت تبدا بالتحليل، يعني تبدا بالمرحله الاولى تشوف مثلا ايش كانت النيدز او الريكوايرمنتس اللي جايه من الكاستمر مثلا للنظام هذا، كيف بدانا نسوي مثلا دوكيومنتيشن للريكوايرمنتس هذه، كيف حولناها الى ديزاين، كيف بعدين سوينا فاليديشن. تمام، بعدين نتكلم الان عن الكومبليت بروبلم اللي هو مثلا الاوبريشنز والبرفورمانس والتست والمانيفاكتشرنج والكوست والسكيجول والاشياء هذه والتريننج والسبورت. بعدين ندخل في الديسبوزل لما السيستم هذا مثلا ينتهي، كيف ممكن نسويه مثلا، هل نتلفه بشكل كامل، هل ممكن نطلع منه في شيء معين نسوي ريسايكلينج واشياء زي كذا، هل ممكن يتم تفكيكه لاجزاء وبعدين يتم استخدامه مستقبلا. يعني تكون الخطه تبعك كامله. وبعدين في الاخير بس انه كيف تدير هذه الاشياء كلها مع بعض، وكذا انت تكون سويت اللي هي اللي نسميها احنا بشكل عام السيستمز انجينيرنج. فهذا الان اللي قلته الان لكم هذا هو الزبده، وهذا هو اللي بنسويه احنا خلال هذا الكورس او خلال المشروع اللي بتاخذه. التفاصيل اللي بدخل فيها انا هذه عشان بس اساعدك انه كيف انت مثلا تحسب الريلابيلتي في معادلات معينه كلنا مرينا فيها تقريبا، اذكركم فيها شويه وناخذها بشكل سريع لانه احنا مش في كورس ريلابيلتي ولا حتى في كورس مثلا سيموليشن ولا في كورس مثلا ماثيماتيكال موديلنج، يعني اعطيكم اشياء بسيطه، حتى الاسئله مثلا في الامتحان او شيء بتكون برضه بسيطه وما بتكونش معقده لانه هذه مش مشكلتنا. احنا مشكلتنا انه كيف نفهم اللي هو السيستمز انجينيرنج، كيف نتعامل مع النظام بشكل عام، وكيف ايضا ايش نصمم او نوصل الى ديزاين يكون شامل لكل اللايف سايكل تبع السيستم هذا، لكل جزئيه فيه، وعندنا كل التفاصيل وعندنا خطه كامله. يعني المشروع انت بيكون معك خطه كامله تبدا من النيدز الى الديسبوزل، وكيف تسوي مانجمنت لكل الاكتيفيتيز ما بين ذلك وذلك، ما بين صفر وما لا نهايه، يعني ما بين صفر وما بين نهايه المنتج او نهايه النظام. ان شاء الله يكون الامور واضحه. خلينا نكمل لانه تقريبا راح الوقت واحنا نشرح اشياء شويه بعيده عن المطلوب. طيب الان زي ما كان في اللي هو characteristics او خلينا نقول خصائص للنظام، في خصائص الان في systems engineering عباره برضه في خصائص ممكن نلخصها انه عباره عن systems engineering is like an applied science. It's dealing or let's say concerned with like the big picture of the system and it's a multidisciplinary field. هذه الثلاث خواص اللي لازم تكون مثلا في بالك. عباره عن applied science and systems engineering applies scientific discoveries and mathematics to make a specific system work. We say it's dealing with the big picture because we say that it's like a top-down design process, and as opposed to starting with the details from the bottom up, we're dealing with like top-down, and we are dealing with the whole life cycle of the system. And it's multidisciplinary, like I discussed with you. You're gonna need a lot of science from other fields in order to come up with the perfect, let's say, a complete plan for your system, which is actually the purpose behind the systems engineering. Application domains of system engineering, we have aerospace, we have like infrastructures, we have communication systems, data and information systems. Especially these days, we are dealing with a lot of data, so data and information systems are taking place in most of the companies now. They have even like departments for that. It's not like before, no one was caring about such stuff, but now it's like one of the main issues or one of the main departments in any system or in any organization. So we're going to have like some data and information systems, healthcare systems, electrical power systems, and production and construction systems, which is the ones that we are really familiar with. We have waste disposal systems because actually to dispose your system, there is actually waste and disposal systems that you can even utilize and use, transportation systems, financial systems, education systems, and you can come up with a lot of examples and applications. هلا عمر، قد نحاول بها قدر المستطاع. يعني الآن هنا أتكلم عن الأنظمة بس، يعني الايروسبيس عباره عن نظام الفضاء والطيران والكلام هذا، اللي هو الاربان انفراستراكشر اللي هو بناء المدن يعني الطرقات والجسور وهذا الكلام. الكوميونيكيشن سيستم هذه انظمه الاتصالات، داتا انفورميشن سيستم هذه اللي هي انظمه البيانات وانظمه اللي هي الانفورميشن سيستم حاليا او الاي تي اللي صارت منتشره وصارت موجوده في كل تقريبا منظمه وفي كل شركه. healthcare system here, that's like one of the most important applications, which is actually الانظمه الصحيه. تمام. وبعدين عندك اللي هو الالكتريكال باور سيستمز، هذا هو النظام الكهرباء، النظام الانتاج، نظام اللي هو التخلص من الويست. تمام. وعندك بعدين انظمه التنقل الترانسبورتيشن، انظمه اللي هو الماليه، انظمه التعليم وغيرها كثير من الايش من الانظمه. ممكن ترجع للكتاب اللي حطيته لك هنا في السورس وتشوف مثلا ايش ممكن انظمه حاطينها او ابلكيشنز حاطينها غير المذكوره هنا في السلايد. اوكي، لكن بشكل عام هذه عباره عن ابلكيشنز كثيره ممكن تاخذها بعين الاعتبار. Now let's talk about the system life cycle. The life cycle includes the entire spectrum of activity for a given system. And here we're talking about the entire spectrum, means, like I said, from needs through disposal. Okay, commencing with the identification of need and extending throughout the system design and development, production or construction, operational use and sustaining maintenance and support, and finally system retirement or material disposal. هذا بشكل عام اللي كان تقريبا في حد من الشباب سالني على اللايف سايكل، وهذا تقريبا في الصوره هنا تصير اوضح شويه، انه نتكلم عن بدايه من النيدز للديسبوزل. فبالنسبه للسيستم لايف سايكل هنتكلم عن اللي هو اللي هو نقدر تقول التوصيف الزمني الكامل لأنشطة النظام هذا، ابتداء من تحديد اللي هو الاحتياجات إلين التخلص من النظام هذا، أو خلينا نقول إعفاء النظام من العمل، وبداية اللي هي التخلص من المواد الداخلة في تكوين أو تصميم هذا النظام. تمام. هذه العملية تمر بها في الديزاين اند ديفلوبمنت اللي هو التصميم والتطوير، الجزء الأولي، بعدين البرودكشن أو الكونستراكشن اللي هو الجزء الفعلي اللي يبدا في عمليه الانتاج والتكوين لهذا النظام، وبعدين عمليه اللي هو الان النظام بيروح على وين؟ بيروح على الزبون وبيروح على الشركه وبيروح على الانفايرمنت بشكل عام. فالنظام بيروح الان على العمليه اللي نسميها احنا اللي هو الاوبريشنال ايج، او خلينا نقول العمر اللي هو اللي بيشتغل فيه النظام هذا. في اشياء كثيره داخله فيها، واهم نقطه اللي هي عباره عن المينتنس هنا المذكوره. بعدين اخر شيء اللي هي فقط اللي هو احاله النظام هذا الى ايش؟ الى التقاعد زي ما يقولوا. النظام هذا في الاخير خلاص بيكون عباره عن نظام اجهد وانتهى. حاليا انت الان في مرحله اللي هو ايش؟ التخلص من النظام، ويشمل هنا اللي هو ايش؟ كيف ممكن تسوي اذا اللي هو الريسايكلينج او نسميها ماتيريال ديسبوزل. وهذه هي اللي ايش؟ السيستم لايف سايكل بشكل عام. في كل مرحله في عندك فيدباك للمرحله اللي قبل، عشان حكايه التطوير انه زي ما اتفقنا عباره عن iterative process. التطوير دائما موجود، ف you're gonna always have some feedbacks. Systems engineering process. قبل ما ندخل على المودلز والاشياء هذه، حابب اوضح اللي هو المصطلح هذا، وخلينا نقول systems engineering process parallel to the system life cycle، بجانب اللي اتفقنا عليه العمر المنتج، تمام، او العمر الكامل للمنتج هذا ودورة حياة المنتج او النظام. There are a series of activities that bring system into being. تمام. المقصود هنا انه في جزئيه اللي هو في سلسله من الانشطه اللي تحط النظام هذا اساسا كنظام فعلي او كنظام ملموس يخدم اللي ايش؟ الزبون. This series of activities is called systems engineering processes, or more specifically system design processes. The systems engineering process is comprised of 7 typical tasks. These tasks is abbreviated or put in like an acronym, which can be pronounced as similar. Okay, so the tasks are: state the problem. عرف المشكله او اذكر المشكله او وصف المشكله تبعك. Investigate alternatives. ابحث عن الايش او دقق في البدائل. Model the system. ابني نظام او ابني عباره عن موديل للسيستم تبعك هذا. Integrate. سوي تكامل ما بين الايش؟ الجزئيات الخاصه بالنظام. Launch the system. نبدا بعمليه تشغيل النظام. بعدين assess performance لتقييم الاداء. And then re-evaluate. فالحرف الاول من كل كلمه في الاخير summarized in acronyms named like similar، اللي هو state, investigate, model, integrate, launch, assess and re-evaluate. هذه هي عباره عن systems engineering process او processes. هذه هي العمليات اللي نقوم فيها لما نسوي ايش؟ او لما نقوم بعمليه تصميم النموذج من وجهه نظر اللي هي ليش systems engineering. From the point of view of systems engineering, we should like understand what are these processes and how every one of them can be detailed. And I think this is like one of the main things that you will need to define when you're dealing with your project. Okay. Systems engineering design is an iterative, top-down, and need requirement-driven process to gradually translate the high-level general system needs and requirements to specific technical system parameters, so that the system can be developed, assembled, installed, and delivered for operations in a well-managed, tightly controlled, cost-efficient manner and within cost limitations. يعني في الأول والأخير لو تتذكرونا في البداية وضحت إنه الغرض إيش؟ اللي هو تخفيض التكاليف وبنفس الوقت نسوي إيش؟ رفع للإفشنسي. ففي الغالب هي عبارة عن trade off between اللي هي اللايف سايكل كوست efficiency والكوست ليميتيشنز تبع الشركة وتبع النظام أو الخاصة بالتصميم، والعملية كلها تتم زي ما اتفقنا من النيدز الى الديسبوزل. طيب بالنسبه للمودلز الان البروسيس هذه عباره عن او الريليشن شيب ما بين البروسيس هذه تم نمذجتها ووضعها في نماذج معينه. تقريبا في 3 نماذج موجوده في الكتب عندكم نناقشها بالتفصيل. I stop here just before the break just to tell you that to actually to manage, or let's say to handle these, let's say, systems engineering processes, there is like different models to do that. I think I have something in the chat. I will just double check it. And these models are, we have the waterfall model, spiral model, and the V model. And we'll just go through like each one of these in a little details. I don't know what's going on. I cannot see the chat. So if someone just type something in the chat, he can just unmute himself and talk. And now, yeah, now I can see the chat. Yeah, it was nothing. Okay, that's good. Okay, so like I said, to understand the relationship between systems engineering processes, and also to understand how the system evolves from one model to another, and the interrelationships between different deliverables, these models should be used, which is actually the systems engineering process models. And the models in the chapter, or this introduction that we're going to discuss, are actually three models, like I have said: the waterfall model, the spiral model, and the V model. Okay, let's discuss every one of these like in details. So the waterfall model is just like an up-down or like top-bottom type of model. This model just takes like every step of the, let's say, life cycle or the design, or let's say the processes of the engineering design from top to bottom, and this is going like a one way, and the other way is going only just for the feedback. So this one was introduced by Royce in 1970 and was initially like developed for software, let's say or systems related to software development. This model usually consists of 5 to 7 series of steps or phases for systems engineering or software development. We have then like another researcher has come, whose name is like Bohem. He expanded this into an 8-step series of activities in 1981. Since that time, this model is used actually to model the activities or the phases or the steps of systems engineering, starting from requirements and specifications all the way to operational development. And it's going through like I said, it's now like an 8-step series of activities. We have the preliminary concept design, the logical design, the detailed design and testing, operational implementation, evaluation and modification, and finally operational deployment, or let's say retirement. This model was a little bit enhanced, and then Bohem come up in 1986 with a different model that's actually based on the waterfall model, but this model coming like it's like now going in a spiral way, which means like an iterative way. He just come up with an iterative approach in order to reduce the risk, or let's say the risk driven, that comes from having only like one direction. It's like it's mainly based on prototyping, and it allows for risk evaluation before proceeding to the subsequent phase. So before going to the next phase, you can just do some risk evaluation and then decide to go or not. And this is actually the spiral model. So it depends on how your system, or let's say how the characteristic of the system, and there is no best model. You cannot really say this one is the best to use or the other one is the best to use, because every system has different characteristics, and you have to find the one that really fits your system. And the final one is actually the V model, and this one developed by like Sally Orsberg and Mose in 2005. It's another extension for the water model, but in this one we have the V shape. Starting with the V, we have like two sides. The left side is for the system definition, and the right side is for the system integration. And we have the implementation, which is the intersection between these two sides. It's actually the implementation. And the system definition starts with conceptual design and finish with the detailed design. And then we have to design to specification or built-in specification. That's actually the implementation comes there. And then we have the development up to maintenance. This is actually the integration side. And the vertical horizon is actually the time and system life cycle. So these are actually the three models that you can actually use to model your systems engineering processes. And like I said, there is no winner in one of these models. It depends on the characteristics of the system that you are studying or you want to engineer. And it's observed that preferences expressed by individuals and groups for one of the system models is subjective. There is no evidence. It's just subjective that this one going to be better, the other one going to be like better than the, or let's say the best, something like that. These all preferences are subjective. There is no evidence or there's no research supporting that. Research is needed to see which model fits what situation better. So like I said, you need to study the characteristic of your system and then decide which one of the models you're going to use. Just I'm going to just open like a small class discussion on, let's say, what are among these processes. If we go back to the processes that I said, like we have like 8 here and the rest of the processes in the spiral or the V model, what actually the common, let's say, the common items that you can spot from these models or from like the processes that actually are modeling. Can you come up with some answers? If we talked about yeah, Muhammad, you can talk. If we talk about all the processes that these models are actually working on, or let's say facilitating or linking relationships.
I think waterfall model is the most used.
Yeah, I know it's because it's like the previous one or the first one developed, and it's like widely used because it's a little bit easier and goes in one direction, which helps in really building your plan like more like faster than the other models. But still, like it depends on the system characteristics. Yeah, like you said, you prefer this one, or maybe you are seeing this one as the frequently used one, maybe especially in practice. But still, the preferences are subjective. There is no research to support that those like, let's say, preferences. What I can say, like, let me say it in Arabic so the students will understand. Like النماذج هذه الموجوده ما فيش حد منهم نقدر نقول ان هو افضل نموذج لانه ما فيش ابحاث تدعم هذا الشيء، لكن بالغالب الووتر فول موديل او اللي هو النموذج الشلال هذا مستخدم خصوصا في الشركات او في خلينا نقول في الحياه العمليه بشكل اكثر، لانه سهل التطبيق، يمر في اتجاه واحد وبعدين يعطيك فيدباك. هو كان اساسا يعني او اول الموديلات اللي تم تكوينها بهذا الخصوص اللي هو تو موديل سيستمز انجينيرنج بروسيسز. السبايرال موديل او الموديل الدائري هذا هو كويس انك تقيم الريسك قبل ما تدخل على اي خطوه مقبله، لكن بنفس الوقت يظل عباره عن اكستنشن للووتر فول موديل، يعني عباره عن تطوير او خلينا نقول تطوير للنموذج السابق. نفس الشيء في الفي موديل، نفس الشيء هو عباره عن اكستنشن او عباره عن تطوير للموديل السابق. فتطبيق هذه اهلا بلال، يمكن توك.
اعتقد انا النموذج الاول الجميل فيه انه في كل مرحله من مراحله في فيدباك لكل مرحله تقيمها قبل ما تنطلق للمرحله الثانيه. لو نظرت لبقيه النموذجين الثانيين وكانه ما فيش مرحلات فيدباك في النموذج الثاني والثالث، لكن في الاول في فيدباك في كل مرحله.
بالضبط، هو يظل الفيدباك موجود لكن تقييم المخاطر غير موجود في النموذج هذا. حتى لو كان في فيدباك تاخذ انت الفيدباك for your let's say future considerations. الميزه فيه زي ما قلت انت صحيح، حتى لو كان في فيدباك او حتى الميزه فيه هنا هي السهوله، لكن الميزه في الجزئيه الاخرى في السبايرال هي حكايه انه الريسك ايفالويشن. هنا في السبايرال موديل ليش ما فيش فيدباك؟ لان انت تسوي تقييم للريسك قبل ما تنطلق للخطوه اللي بعد. فلو وضحت الفكره، هنا يحصل تقييم في كل مرحله قبل ما ننطلق المرحله اللي بعد. يعني الفيدباك already included but it's not like in the previous one, like it's not going there because it's actually considered before going to the next step. For this one, the feedback means you may not have time to do anything with it. It's just a feedback for what's happening, and you will move forward. But for this one, you need to do evaluation before going to the next step. And for the V model, it's actually constructive, and you can say that everything here is clear, and it has been let's say categorized into like 3 stages, or let's say 3 categories: the system definition, the system integration, and the implementation. So you can work on these 3 like separately and also like manage your processes. So it's like I said, you cannot say like one is the optimal. Let's talk about optimality or the best. It's subjective. More research is going to be required. And the question here is systems engineering the same from product development? What I'm saying here, I think I have answered the question because I talked with Rafat about it. So I have answered this question, so I'm gonna just take the discussion out and just give you it's like the production development process, which, like I said, it goes from the beginning with the planning and end up with the production approval. When you have the production approval, then you finished. But for systems engineering, we are going from the beginning, the whole life cycle up to the disposal. So even we consider also like the production, the construction, and then the operational with the maintenance and everything, and then the final stage, which is the retirement or the disposal. But for product development, we just do the first stage, which is the design and the, let's say, the production approval. It ends up there. So now systems engineering should be clear, at least like or the beginning, or let's say as an introduction. We have discussed a lot of terms and a lot of models and processes. And let's now move to the last item of our presentation here, or our lecture today, or our introduction of this course, which is why do we study systems engineering? This question actually can be answered by the, let's say, either the constraints or maybe the complications or the complexities that we are facing. Like I said, we're studying the whole life cycle. That means there are going to be a lot of problems to deal with. And that's actually why we need to do systems engineering, because dividing every one of those like and studying them separately, that's going to be, that will not be systems engineering anymore. It will be falling in like for the, if we're going to take only the design stage, that's going to fall in the product development. It's not going to fall in the systems engineering field. And one of the most important, let's say, considerations for using systems engineering are the challenges that the current environment has. So can you add like at least list like one or two challenges that you may find in the current environment? If you're like, let's say now we're going to design a system and you want to do it from the systems engineering point of view. So what's going to be the challenges, or let's say the complications that you may face during this process? Let's come up with one or two based on the definitions and all the stuff that we had from the first slide so far. Let's see about that. Anything here?
يا دكتور.
Yeah, any challenges like examples، أمثلة للمعوقات أو التحديات اللي ممكن تواجهها أنت إذا حبيت مثلا تسوي system design from point of view of systems engineering، إذا حبيت تسوي خطة كاملة للسيستم تبعك. إيش مثلا المعوقات أو التحديات اللي ممكن تواجهها؟
gathering information, doctor. Gathering information, I think it's the most difficult, I think.
That's a good one.
And it's also reliable information, because you cannot gather any information just.
Okay. What else? Can we have like some other examples? Okay, that's fine. We talked about a lot of things like complexities, having a lot of like difficulties, like system of systems and all this stuff. So let's see what we have here. Like we say that all systems are dynamic. Yes or not? We said in the classifications, and we have mentioned that in systems engineering, all systems are dynamic, or because they are like interacting with the environment. So we have constantly changing requirements. I'm gonna start from the left side, from the upside, like from the upper side and the left side of the screen. We have constantly changed requirements. If we can name that as a challenge, because systems are highly dynamic in practice or in real world or in real environments. We emphasizing more on systems than components, because we said that we are studying system in whole, and we are also studying the whole life cycle of the system. We have increasing systems complexities. Systems are really complex. And now we have involving of technology. And every time technology changes, that's going to mean like we have like more changes and more complexities to deal with, okay? We have extending system life cycle, because we are studying the whole life cycle of the system. And also we have greater utilization of commercial off-shelf products, which means we are using a lot of ready products in the designs. And this one also can be a problem, because we need to find, let's say, the best or let's say the optimal utilization of such resources. We have increasing globalization these times, or let's say with the era of having supply chains and global supply chains. Companies are really aiming for globalization, as it's really helped them like managing their operations, and also help them like opening relationships with some other companies that they can really benefit, or like find like new markets and all this stuff. So that's following the category of increasing globalization. And we have greater international competition, and we have like more outsourcing. We know that even like maintenance in some companies are done by outsourced companies, because they don't really worry about maintenance. So they just, when they buy the machine, they outsource the maintenance of that machine, and they get rid of this headache. And that means they will really outsource some of the activities. So this is like some of the challenges that we may face. And this is why we need systems engineering, because without systems engineering, you cannot really deal with all these challenges at the same time. Let's talk about more details. Let's say the cost impact due to changes. How you can imagine that, let's say if we're gonna really make it in a curve or in a picture, how the cost impact look like due to changes. So this is actually the life cycle, if we're gonna assume, of the system. It goes from the conceptual design up to the production or construction. We are not dealing with the rest of it, just up to production and construction. And we have the cost of design changes. This is just for the design. Okay, you can see that the best practice is actually to do all the changes in the early phases, either the conceptual design or the primary design. And it's best to be done on in the conceptual design stage, because after that costs will change dramatically. And you can see that if you try to make any changes during the production or the construction stage, that's gonna cost you like the maximum, or let's say the most, is the higher costs are gonna come from having any modifications or any changes at this stage of the system, of developing the system. So you can see also that in this is just adopting this practice, which is actually coming up with the changes before the production construction, will reduce the peak, or say the maximum cost that you may face, mostly like by 5% or maybe 40%, sorry, 50% or 40%. So when we are really using systems engineering, we will be able to tackle, or let's say, these problems earlier, and we'll be able to reduce costs. So this is like one of the needs, or let's say the important aspects that maybe systems engineering gonna help you with. So it's actually gonna help you with overcome challenges, reduce cost or the impact of cost due to changes, and gonna create a balance between system cost and effectiveness. Because in the real world, it's creating a balance is really difficult. It's always imbalanced, because high life cycle costs, it's there. You cannot avoid it. You need really just to decrease it. You cannot eliminate it. It's just need to be decreased like as much as possible. And we have effectiveness systems with bad designs, or let's say with bad management and bad also considerations for designs for all the stages of the life cycle of the system, will have low effectiveness. So if you need to create a balance between effectiveness and life cycle cost, I'm talking here about life cycle cost, not the cost of only one of the stages. We're talking about life cycle as a whole. Okay, like we said, from needs to disposal. So to create a balance between these two important things, or let's say two important aspects of any system, you need to use systems engineering. And for the life cycle cost coming from, like I have listed here, like some of the examples as per the textbook. We have research, design, and development cost. We have construction cost, production cost, system operating cost, maintenance and support cost. We have retirement, material recycling, and disposal cost. So like I said, from design to disposal, okay? All these costs will result in a high life cycle cost, how to minimize this one, and at the same time, keeping your system effectiveness. That's one of the main important reasons for why we are using systems engineering. And for system effectiveness, actually coming from system performance, from availability, from dependability, from reliability, from maintainability, from humanability, and from supportability, which is all as like aspects of let's say system design that we are dealing with, because we are said that we're going to deal with reliability when it comes to systems engineering. And also we have constructability and producibility also. system quality, disposability. Your system should be disposable, or you can really recycle it or dispose it without affecting the environment. And there is also some other technical factors. So all these factors, if you want to really find a balance between these, let's say, aspects, you're going to really need to use systems engineering, because it creates, or let's say eliminate, that imbalance issue that actually happening in the current environment. So going back, I will start in Arabic now. Like we said, كما تحدثنا يعني سابقا، هذه عبارة عن التحديات اللي بنواجهها. في تحديات كثيرة، من ضمنها أولا التوجه العالمي للشركات، استخدام المنتجات الجاهزة، التعامل مع دورة حياة المنتج بشكل كامل، الزيادة في التعقيدات للأنظمة، التركيز على النظام بشكل عام أو كامل مقارنة بالتركيز على المكونات. التركيز على المكونات أصبح أسهل، لكن التركيز في السيستمز انجينيرنج حنركز على السيستم بشكل عام. وأيضا عندنا اللي هو التغير الدائم للمتطلبات الخاصة بالنظام. هنا ناقشنا اللي هي عبارة عن الكوست، متى يفضل انه نقوم بالتدخل. دائما يفضل نقوم بالتدخل قبل الوصول الى مرحله الانتاج، لان عند مرحله الانتاج الكل مش شايف الكيرف او الانحناء، قصدي اللي هو اعلى نقطه في الكيرف دائما تعطيك اللي هي الاعلى تكلفه. فلو ركزنا البيك او قمه الكيرف هنا في اللي هو في حاله انه قررنا نسوي تغيير عند البرودكشن ستيج، يفضل دائما نسوي التغيير في مراحل التصميم، بيكون التكلفه اقل. وهذا اساسا الديزايربل والديزايرد براكتسز، وهذا ما تقدرش تسويه الا اذا كنت انت شايف زي ما اتفقنا، انت شايف النظام ككل وتتعامل مع اللايف سايكل حق المنتج كله. وهذا فقط غير موجود الا في الا في السيستمز انجينيرنج، او غير ممكن تطبيقه الا في حاله انه اتجهت الى استخدام السيستمز انجينيرنج في حاله تصميم المنتج تبعك او النظام تبعك بشكل عام. وهنا تكلمنا انه في عدم توازن ما بين اللايف سايكل كوست او التكلفه دوره حياه المنتج بشكل كامل والeffectiveness في النظام. فدائما high cost would lead to low system effectiveness. فكيف نتغلب على هذا، او كيف نوجد توازن من هذه الجزئيتين، هذه هي وظيفه السيستمز انجينيرنج، وهذا اللي ما يقوم به السيستمز انجينيرنج او المهندس اللي تخصصه سيستمز انجينيرنج. هذا الهدف الاساسي. نقطه اخرى، another point is the total cost visibility، اللي هو اللي يظهر لك من التكاليف غير التكاليف المخفيه. واعتقد هذا المبدا تقريبا قد مر عليكم اعتقد من قبل. هو المبدا انه معظم التكاليف مخفيه، most of the costs are like not visible, and the visible part of the cost is just only the cost related to the acquisition, which is actually for research, design, test, construction, and production. The rest of the costs, like costs due to system operations, the cost due to maintenance and lifecycle support, we have costs due to like system effectiveness and performance loss, and we have costs due to retirement, or let's say material recycling or disposal. All these costs are not feasible, and in order to be able to attract, or let's say to see all these activities or costs related to all these activities, you need to follow a systems engineering approach in order to have an overall look, and in order to have in order to deal with the system as a whole, not dealing with every single stage separately from each other. وهنا ناقشنا حكايه اللي هو التكاليف. معظم التكاليف غير ظاهره زي ما اتفقنا. التكاليف الظاهره فقط تكاليف المتعلقه بالنظام، اللي هو الابحاث والتصميم والتكوين والانتاج. بقيه التكاليف المتعلقه في عمليات النظام، في الصيانه، في زياده الفاعليه وخساره ايضا الاداء، الاشياء المتعلقه بالريسايكلينج والديسبوزال، اللي هي اعاده التدوير والتخلص من النظام عندما ينتهي عمره الافتراضي. هذه كل التكاليف غير ظاهره، وهي اساسا ستقود في الاخير الى اداره سيئه او poor management. To overcome this also we need to apply, or let's say to follow systems engineering approach, or we need to deal with the system from the point of view of systems engineering. We have commitment of life cycle costs. Abdul Jalil raise a hand. You can talk, Abdul Jalil.
But doctor, I mean, this picture, it was just for poor management. That means if there is, successful management, they can see all that, costs.
If you did not consider the whole life cycle, how are you going to see it? Because it's going to be dealt with like separately. So with poor management, yeah, you're gonna deal up with what's visible. But as a systems engineer, you need to deal up with what's not feasible to you.
Okay.
That's the
yeah.
difference. That's the
Okay.
difference.
Thank you.
Welcome. And there's actually the commitment of life cycle cost. This one gonna list you, let's say, the life cycle cost, what is actually the opportunity for reduction, the cumulative cost, and the actual program expenditures, or let's say the cost that for the actual program. If we're gonna forget the dashed curves and just look for the shaded area and the linear curve, we can find that like we said previously, the opportunity for doing any life cost reduction should really start at the beginning, because as soon as the system is moving in time in its life cycle, the opportunity for reducing life cycle cost is really decreased to the minimum. And when you start, like when you just dispatch the system for utilization and for working, or maybe to the customer, there will be like even like no opportunity for doing any reduction. And for the cumulative cost, it's actually the opposite of the opportunities, because the cost of doing any reductions will be higher when the product is in the use with the customer, I mean. And at the beginning is going to be like 0 or maybe the minimum. And same thing is the actual program cost, which is go a little bit higher with time until it reach the ultimate, let's say, cost when the system or the product is actually in use or delivered to the customer. So this is actually the commitment of life cycle cost. And systems engineering in general can really handle, or let's say deal with such let's say reductions, because we are like I said, we are under systems engineering, we are looking to the whole life cycle of the system, and like under this consideration, I think you will be able to capture the opportunities where to reduce life cycle costs, instead of, let's say, dispatching the product or the system to the customer and then look for solutions for reducing cost. And this is actually the value of systems engineering. The value of systems engineering comes like, it's actually determined to you where the opportunities are, starting from the concept, through the design, through development, through production and construction and testing also, and then the operational, and from operational through disposal. So if you try to really come up with any cost reduction, it should be at the early stages, because the cost to extract defects at these stages are really small, and it's increased dramatically, and it's really in a higher, like from 3 to 6 up to 5 to 1,000 times when it comes to extracting those defects in the production stage or maybe the operational stage. Okay, and the committed costs are mostly like, it's going to be like mostly in like for many researchers, they reported like 70% after the conceptual design, up to 95% after the production stage. And the value of systems engineering is actually systems engineering efforts reduce cost and schedule overrun. And I'm gonna leave that like for like as a discussion, even like you can like do it like now in class, or we're gonna do it like in next classes or next lectures. Why do you think that systems engineering is gonna really afford you such option? Because we have discussed that, and I'm gonna take you back to you have to think back about the characteristics of the system, which we are the interaction, the hierarchical, the emergence, the dynamic, and the interdisciplinary. And why systems engineering? Because we know that systems engineering is actually dealing with all these characteristics as a whole and the whole life cycle, and that's why systems engineering is going to have like a great value compared to any other approach when dealing with such problems and challenges. Okay, this is the final item in the lecture. I'm going to take you through like a brief history of systems engineering. So before 1940s, it was the machine age, and after 1940s is the systems age. So systems engineering is a recent approach, which comes after the machine age. To give you more detail, when we were actually, or when the world were actually like in the machine age, we have the reductionism, which is everything can be reduced, decomposed, or disassembled to simple individual parts. And we're having like an analytical way of thinking, which means you're going to take a part, what is to be like, you're gonna take like some while to explain what you are thinking, or maybe what you want to do, or what you're gonna analyze, and then you're gonna explain the smaller parts. You're gonna start with the small parts, and then the whole is the sum of its parts. This is the analytical way, and that's what was the thinking. So actually, the whole system is just the summation of its parts, and that's it. And then come the mechanism, which means we have cause and effect, deterministic thinking, and then we have closed system thinking, ignore the environment and the phenomena, or the phenomenon that the environment is, or sorry, the system is in actually. And finally is the mechanization, which means we know that the industrial revolution was in the 19th and the 18th, and during the 18th and the 19th century, the machine substitutes people, starting from those centuries or from those times, for physical work. And we started using the term like dehumanization of work, which means now they are using people like the minimum, and for risky operations, most usually we have machines to do that work. That was the machine age and the machine age thinking. Examples of machine age thinking was the ancient roots that we have, like we know that Aristotle, and also we know Archimedes and what they've come up with. And in biology, we have study of cells and organs. That was like a machine age thinking. They don't study the human body in general. They just focus on cells and organs. And for physics, we're studying only atoms. We're not studying the whole structure of the material. And for like Taylor, like the scientific management that Taylor proposes is not working. We know that it's not working anymore, because now we have the Toyota production system and the Ford production system and these advanced lean manufacturing systems and the lean thinking instead of machine age thinking, which is actually system thinking, or let's say information age thinking. Okay, so those were just like some examples. You might be able to find even like other examples if you go through the textbook, but these are actually the examples of machine thinking. I don't want to put this point in, but maybe if you can come up with some examples, or maybe like the strength and weakness of the machine age thinking, we can discuss that in details. But I think I'm gonna just postpone that, because I will need to discuss with you like the final slide and then go through the course syllabus and details of that. So for the system age, before going into any details for the course syllabus and the structure of the course, I will discuss with you the final slide here, which is the system age. This age known also as the information age of and also the computer age. It started after 1940s, and especially in 1980s and more in 1990s. It's supplementing the machine age thinking. In this age, we have like different terms here, like expansionism, and that means like we're expanding our thinking. We are not thinking now like only like in the machine age. We are not thinking of reducing. We are now expanding. All objects and events and all experience of them as part of a larger wholes. Now we're talking about the system in general. We are considering the stochastic view instead of the static view as in the machine age thinking. We're talking about stochastic view of the systems. And now we're also having, instead of analytical thinking, we're having like synthetic thinking or system thinking. Instead of focusing on explaining the whole, but taking it as a part, and just saying that the whole is just the sum of the parts. In the synthetic thinking or the systems thinking, this is not the case. It's exactly the opposite. So synthetic thinking focuses on explaining something in terms of its role in the larger system. So the whole system is not equal to the sum of its part. Sometimes is more, sometimes is less. So that's actually systems thinking. And finally, technologically oriented, which means systems has purposes now. And we're focusing more on human aspects of organizations, design, and management. That's actually the system age thinking. Let's discuss now machine age versus system age. Machine age thinking, we say this like reductionism, and here we're talking about expansionism. Well, in machine age thinking, we're talking about analytical thinking. We're going more into like details of the parts in an analytical way. In systems age thinking, we're talking about synthetic, which means we're thinking about the system in whole. We are not considering system as sum of its parts. It could be more, it could be less. And the final one is like actually the mechanization. In the machine age thinking and in the systems age thinking, we have the technologically oriented point of view. So these two eras shows, or let's say show continuous human inquiry to understand the world. They are complementary, but not contradictory. System engineering is a more recent phenomenon. That's what you should know. And understanding the history helps us to think critically. That was like a brief description of the history of systems engineering. One last thing, there is like an international, or let's say we can name it the International Council of Systems Engineering. It's abbreviated as like INCOS. Is a non-profit membership organization founded to develop and disseminate the interdisciplinary principles and practices that enable the realization of successful systems, which we can say that actually they are the most recognizable membership or organization that actually have a foundation for systems engineering as a discipline, okay, or as a field of study, or as a field of practitioner. So the mission is to share, promote, and advance the best of systems engineering from across the globe for the benefit of humanity and the planet. The vision is that the world's authority of systems engineering, so they are most, like I said, is the most recognizable organization that actually explaining and defining the systems engineering concepts and terms as a field of research or as a field of practitioner practice. And finally, I have provided you with the website for that organization. There is some misspell there. I will fix it, and then I will send you the correct one. So this actually was the introduction of this course. We have finished, I think, like most of the points that we want to talk about. Now let's talk about course syllabus. I just want to determine everything, so I will just like modify the files and then send them to you as a final version of those like syllabus and the project consideration. So I'm seeing that I'm having like more students here as I have did the attendance. So could you please write your name in the comments so I can have your attendance? I have only 8 of you, which means like maybe 6 more. Fadl.
نعم.
Yes, I'm just looking for the new students in the chat so I can take your attendance. I will do that before going through the course syllabus, okay? So please write your name in the chat. So that's what helped me in taking your attendance. As per the syllabus that I have posted through the WhatsApp group, and also I have uploaded to the Google Drive folder of the project, of the course. Here we have the meeting times. We have 2 lectures, 2 sessions per week, 3 hours per session. The times are 7 to 10 p.m. I don't know, maybe next Wednesday, just write it down. Next Wednesday, we may start like 4 to 7, only next Wednesday. I have some plans after 7. So we're gonna start 4 to 7, okay? Next Wednesday, only next Wednesday. I will send like a reminder to the WhatsApp group just to remind you. Course evaluation is going, please mute yourself. Salah, mute yourself, yeah, okay. So, like I said, the course evaluation is going to be like, it's gonna consist of like a lot of activities that we're gonna do in class. We have class exercises. Those exercises will be in class. I'll just prepare some exercises. I will take 5 out of 8. And that's gonna be like 5% of your evaluation. We have pre-assessment. Before going like through the Mathematica part of the course, I'll just give you like an assessment, which is going to be like a couple of problems to solve. Just I want to know like how much you know about these technical stuff that we're gonna need in the course. This way I will be able to prepare the lectures in a way that to cover the shortages. And if you really did well, means we will just like go through every like chapter, or let's say field of these like technical issues. I'm not gonna go into like depth, so we're gonna take it like as an overview each of these chapters because it's a little bit difficult to go in details. I'm gonna need at least like 2 lectures for each of these aspects, okay? And we have 2 assignments, only 2 assignments. Each assignment is 5%. And by the way, the pre-assessment is 0. There's no mark. I just want to know like the overall performance that you're gonna have. So that's my lecture is gonna depend on your performance in the pre-assessment. And the assignments, you're gonna have like 2 assignments. I will show you the schedule when they're gonna be due and in which date. And we have class activities. Those class activities will be sent to you directly after class. If we have something to practice at that lecture, there will be also like non-graded, non-marked, but it's up to you to deal with those like activities. I will send you the solutions like 1 week after. Like as soon as I submit an activity, like 1 week after, I will submit the solutions. So you will have the activities and the solution at the same time. For the group projects, I'm like between doing a group project or a midterm. So it's up to you now to decide. Either we have group projects or maybe like midterm, and the group project is going to be like 35 and the final exam is going to be 50. That's about the course schedule and evaluation. One after that is the course outline. I just posted like a detailed outline for the weeks and the dates. Hopefully, let's hope that there is like no mistakes here, but even if there's any mistakes, just let's spot any mistakes there and there. Let me know and I will fix them, okay? So we have the introduction, which has been done today.
دكتور مجيد بليز.
Yeah.
دكتور مجيد بليز العلامات خلاص هذا الفاينل ما not any.
We will discuss that. No, this is open for discussion. الدرجات مفتوحة للنقاش، عشان كده أنا خليتها على الأخير عشان ناخذ راحتنا نناقشها بكل هدوء لأنه خلصنا المحاضرة. اوكي فخلينا نخلص كل شيء. هنخلص كل شيء يعني تقريبا الكورس بيكون عبارة عن تمارين. التمارين هذول بيكون في تمارين ان كلاس، يعني برسل لكم التمارين يا اما بتحلوها وتصور وترسل لي مثلا على الايميل الحل، تمام؟ او بشوف طريقه او على الواتساب بس على الخاص مش على العام، تمام؟ او بشوف طريقه مثلا انه نقدر على الزوم اسوي مثلا اللي هو مالتيبل تشويس يكون اسهل وتحل انت بعدين وتجاوب على الزوم مباشره. مش اذا كانت الطريقه هذه افضل.
ممكن يا دكتور على جوجل فورمز حيكون كويس لو
جوجل فورمز بشوف اذا في طريقه اقدر اصير فيها المسائل الرياضيه بحيث انها تصير مالتيبل تشويس، بس كده بيصير الطالب مظلوم شويه لانه فقط بيختار الناتج النهائي والخطوات كلها بتكون يعني بيكون تعبر على الفاضي. فبنشوف الاشياء اللي تنفع فيها مالتيبل تشويس والاشياء اللي لازم كتابه فتكونوا تصوروا مثلا ترسلوا لي على الواتس او على الايميل. هذه بتكون ان كلاس. طبعا هي في الاول والاخير عشان التحضير، يعني انا كذا دائما عشان التحضير اسوي اكسرسايزز بدل ما اقعد زي اليوم جالس احضر يدوي والشباب مرسلوا ليش الجدول والتعب هذا.
طيب يا دكتور يعني الحضور عليه 5% يعتبر حضور؟
لا هو مش حضور، هو بيكون حضور بس بطريقه مختلفه. بنسوي كلاس اكسرسايزز، بنحاول نسوي 8 منها بتستفيدوا ومنها بشوف مثلا انه الكل يفهم المحاضره ولا لا، لانه في شباب معترضين على الانجليزي، فاهم قصدي؟ فاخاف انه يخرجوا مش مستفيدين، فبيتضح لي من الحلول تبعهم او من الردود تبعهم على التمارين اذا كان في شيء لازم اوضحه ولا لا.
فيدباك
لانه صعب اقعد اسوي كل شيء عربي وانجليزي، بعض الاحيان يجي انفصام بالشخصيه، فاهم قصدي؟ فيا كذا يا كذا. انا بكلم الدكتور مختار بالموضوع هذا، يا كذا يا كذا لانه كذا تعب. كذا تعب، فاهم قصدي؟
ايش يعني يا دكتور؟ تقصد انه بيكون كله انجليزي؟ تقصد
عربيه ام انجليزي اللي يريحكم. ما مستحيل اسوي حاجه متريحه.
لا.
اذا كان صعب الانجليزي فبخليها عربي والسلايدات تصير انجليزي عادي.
انا رايي يا دكتور انا رايي انه يكون انجليزي بس ترسل لنا السلايدات قبل عشان الطلاب يحضروا ويفشوا.
انا قد سويته كذا بس كانت قبل بساعتين. المره الجايه برسلها ان شاء الله قبل بيومين او 3 ايام.
ايوه كذا وخلاص.
ايوه
لانه بصراحه الماتيريالز اللي عندي مش بالشكل اللي انا حابب انها تكون، فقاعد اسوي كل شيء من الصفر.
ايوه فهمت. في
خصوصا الماتيريال السابقه ما كانش فيها اي رياضيات، اي تكنيكال ايشوز، كانت كلها كلام واشكال. فما ينفعش. انتم مهندسين فلازم اخذكم شويه على الريلايبيليتي، لازم اخذكم شويه على السيموليشن، لازم اخذكم شويه على الماثيماتيكال موديل. نقول على اي اساس بتخرج فاهم سيستمز انجينيرنج اذا كنت مش عارف تسوي اي شيء من الاشياء التكنيكال، فقط حافظ الاشياء النظريه وبس. فكذا ما بيكونش سيستمز انجينيرنج، كذا بيكون كلام انجينيرنج. اوكي
تمام.
دريخ انجينيرنج دريخ.
ايوه، فبناخذ اشياء تكنيكال لازم عشان بس نفهم كيف نسوي الدراسات الاقتصاديه للسيستم، كيف نسوي دراسه الريلايبيلتي للسيستم. لان انت لو اتفقنا على المشروع، كيف بتسوي لي ريلايبيلتي للمشروع وانت مش فاهم كيف تسوي ريلايبيلتي؟ بعضكم قد ما يكونش اخذ ريلايبيلتي خالص. فهذه الكلاس اكسرسايزز والبري اسسمنت بيعطيني فكره انه وين اروح، مثلا اروح عميق شويه ولا اروح خفيف، ولا بس اعطيكم المعادلات وارتب لكم الشابتر كذا كمعادلات وناخذ امثله بسيطه وخلاص. لان هي مش صعبه، هي سهله يعني. في الاخير والاخير احنا ما بناخذش كانها كورس ريلايبيلتي، لا ما بنروحش على التفاصيل. يعني باخذ لكم مثلا لو كان السيريز سيستم، البارallel سيستم،
المين ايدياز يعني
الكومبلكس سيستم، عشان بس لما تجي انت في النظام تبعك تسوي لي فلوت شارت، يعني تسوي شويه افتراضات للريلايبيلتي حق كل كومبوننت، وبعدين تحسب لي الريلايبيلتي حق السيستم ككل، بحيث انه لازم يكون عندك الاشياء هذه. وفي الاول والاخير اذا احتجت تسوي محاكاه لازم اشرح لكم شويه على المحاكاه. قد شباب منكم قد يحتاج مثلا يسوي ماثماتيكال موديلنج، فلازم اشرح شويه على الماثماتيكال موديلنج، مثلا اللينير والانتجر بروجرامينج والكلام هذا. وبعدين شويه على الايكونومكس، اذا حابين تسوي مثلا دراسه اقتصاديه لازم ندرس الاشياء اللي تتذكروها تبع الانترست وكيف نحسب اللي هو البريزنت فاليو والفيوتشر فاليو والاشياء هذه كلها قوانين خفيفه واشياء خفيفه، لكن اشياء لازم الكل نفهمها عشان نصير خرجنا باستفاده كبيره من الكورس، غير الاشياء النظريه
طيب
فقط.
بس يا دكتور عن اذنك، بس في الفاينل مثلا اكزام هذه الديفينيشنز وهذه حفظ هذه، ولا وبين السطور الاسئله، ولا على طول على الفهم وخلاص؟
تقريبا انا بخليها كلها مالتيبل تشويس. انا نظامي بالامتحان النظري كله مالتيبل تشويس. النظري اللي هو النظري السيء اللي صعب حفظه يعني. النظري اللي هو سهل حفظه مثلا هذا ممكن يصير مثلا اذكر لي مثلا 3 خواص 3 عناصر حاجه زي كذا، اذا بعطيكم اسئله مباشره منه.
يعني مو قصه تروح احفظ
والبقيه بيكون رياضيات. لازم تفهم قبل ما تحفظ، لازم تفهم
بالضبط. خلاص تمام، اوكي. على الفهم
لما
يعني
تحفظ لازم
اكثر.
تفهم صراحه.
بالضبط.
لازم الكل يفهم
يعني
عشان يقدر يجاوب.
يا دكتور البروجكت
الايش؟
يا دكتور البروجكت كيف؟
البروبابيلتي بسوي لكم ريفيو.
المشروع
هذا اللي اقدر عليه، بسوي لكم ريفيو كامل صراحه. ما اقدرش اسوي اكثر من محاضره صراحه يعني. فلازم تراجعوا شويه في بالابندكس، بالتكست اللي حددته انا للكورس، في بالابندكس يعني فصل كامل في كل التفاصيل. انا بحاول امشي على الاشياء الاساسيه بس عشان لما ندخل في الريلايبيلتي تكون فاهم ايش يعني اكسبوننشال ديستريبيوشن، ايش يعني وايبل ديستريبيوشن والكلام هذا. فبحاول امشي على الخفيف بس ما بقدرش ادخل في التفاصيل. اذا محتاجين تفاصيل بواحد من المواضيع انا بحاول ارسل البري اسسمنت، لانه احنا بنبدا بالتكنيكال ستاف من الليكشر الرابع. بحاول ارسل البري اسسمنت يوم الاثنين او يوم الربوع القادم ماكسيمم، تمام؟ فحاولوا تحلوه وترسلوا لي بسرعه، بس بشرط تحلوه بدون ما تستعينوا باشياء كثيره، عشان بس اعرف مثلا ايش اللي عندكم، تمام؟ لانه ما عندكمش في عندي وقت احضر، فلازم اجهز كل المحاضرات بسرعه. فاذا كان الوضع يعني اذا شفنا الوضع سيء بصراحه تمام، بناخذ تفاصيل اكثر ونحاول مثلا نكنسل واحد من الفصول هذه ونركز اكثر على الفصول اللي هي التكنيكال غير النظري، تمام؟ ونحاول الفصول النظريه نخليها للاخير اذا قدرنا يعني الاشياء النظريه بحاول اخليها على الخفيف ونبدا بالاشياء التكنيكال. وبرضه الاساينمنتس بتخليكم تقراوا. الاساينمنتس في 2 اساينمنتس بقسمهم نصين، نص بخليه على النظري مثلا، نص على العملي. وان شاء الله الاساينمنتس بتفهموا منها اشياء كثيره. في حد يتكلم يا شباب؟
في حد بس ما ادري مين.
اذا هذا رجعنا قفلوا المايك عشان بس النويز. ايوه تمام. فهذا فيما يخص مثلا الكلاس اكتيفيتيز زي ما اتفقنا، هذه بتكون مسائل. صعب انا اقعد اشرح مسائل كثيره في السلايدات، فبناخذ مثلا مثالين على كل جزئيه، والبقيه بخليها مثلا زي الكلاس اكتيفيتيز. هذه انت تعتبر بالنسبه لك ما تعتبرش واجب، لكن لو عندك وقت ممكن تمر عليها وتحلها يعني وتستفيد بعد كل محاضره. برسل لكم الحلول تبعها طبعا اكون بعد اسبوع، يعني اخلي الشباب يحاولوا فيها وبعد اسبوع ارسل لكم الحلول تبع الاكتيفيتيز هذه. بالنسبه للجروب بروجكتس انا مش من مشجعين المشاريع بصراحه، لكن اذا النظام كذا انا تكلمت مع الدكتور مختار.
لا بس يا دكتور اوكي
النظام انه في مشروع، تمام؟
بس اقصد انه كن من مشجعين دعم الدرجات.
الدرجات مش نختلفش عليهم، بالاول والاخير احنا هنا طلاب دراسات عليا، الدرجات اخر حاجه المفروض تفكروا فيها. خلاص انسوا لي التفكير تبع البكالوريوس هذا، انسوا تماما التفكير بالدرجات. الطالب اذا خرج من عندي من الكورس وهو مش عارف يجاوب الاسئله هذيك معناته انا اللي غلطان مش هو، لانه هذا طالب دراسات عليا ومعناته انا ما قدرتش اوصل له المعلومه، معناته انا مدرس فاشل. تمام؟ فاللي معي هنا لازم نخرج كلنا واحنا عارفين كيف نسوي بلان للسيستم تبعنا من صفر، من الف للياء، من النيدز الين الديسبوزل. لازم تعرف تسوي بلان لحاجه زي كده. فعشان تسوي البلان هذه صعب اقعد اشرحها لكم كذا نظري زي اليوم مثلا نقعد نتناقش، الا اذا كنتم بتسووا فيها مشروع. ايوه كذا الفكره بتتضح وبتتكون في عقلك بشكل اشمل. انا عارف، بس اللي اعرفه انه الكورس بيخلص على شهر على شهرين، فحكايه المشروع في الفتره هذه هذا انا بصراحه بما انه هذه مسجله مش اقدرش اقول الكلمه، لكن بصراحه هذا يعتبر شيئا ما في شويه مغالطه يعني. فيا اما بظلمكم بالتقييم يا اما بتروحوا تجيبوا لي مشاريع جاهزه، وهذا اللي انا اكرهه تماما، لانه اذا حصلوا شفتوا لي مشاريع جاهزه معناته بتاخذوا صفر. فبالنسبه للمشروع اذا بتاخذوا مخاطره المشروع مش المترم، ما بقول لكمش ان المشروع بيكون سهل، يا 15 صفحه مش طالب منكم انا كثير، لكن بشرط نطبق الاشياء بشكل مختصر وواضح، يعني التحليل خطوه 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 الين نخلص. يعني بنمشي مع بعض، كل ما ناخذ حاجه في الكورس بتطبقوها على
خلاص
على السيستم اللي
مترم
بتاخذه.
مترم وخلاص يا دكتور مترم.
او ناخذ مترم. انا
إذا
بناقش الدكتور مختار بالنقطه هذه. اذا كان لازم بروجكت معناته خلاص امركم لله. اذا كان في مجال انا افضل انه تكون ال 35 هذه ميد تيرم وفاينل تيرم، بس كده بيكون الامتحان كله 85 كثير ثقيل عليكم.
يا دكتور
لو حظ غلط
عفوا
لو حظ غلط لا سمح الله.
عفوا
معلش ايوه تكلموا
عفوا يا دكتور. هو طبعا التقسيم على اشوف هو بعضهم قد تعمل بروجكت وقد تعمل اختبار نصف ترم. اذا انت تشتي اللي بالاخير انت اللي تقرره، قد تقرره انت تشتي نصف ترم تمام.
حلو، يعني في
تشتي
دكاتره ما
بروجكت
بتسويش
تمام.
مشروع.
احنا كنا من قبل
كويس يعني اي كويس.
طبيعي بالاخير القرار لك، يعني مش انه
كمل اوكي.
القرار بالاخير لك يعني. وانت شوف اللي هو بالنسبه لنا يعني نحن جميع الطلاب تقريبا الماجستير اكثر ناس تشتغل وتدرس، وحلو ان الدراسه عن بعد وهروب من الحضور للجامعه، ومتعبين احنا بالحوبان وناس بالحديده وناس مداري فين بصنعاء، يعني متعب الوضع. يعني شوف اللي هو انسب لنا من ناحيه هذه هل هو اختبار وبنكون ان شاء الله مبدعين فيه، او انه المشروع ما يكون مبدعين فيه.
القرار لكم. اذا حابين نمشي في مشروع انا ما عنديش اي مشكله، تبداوا من اليوم، يعني عندكم من اليوم الين انا بوريكم الجدول يعني. فلازم كل واحد منكم يجي لي عنده فكره بسيطه، يعني بنناقش يعني اللي هو دقيقه واحده يحاول يجهز برزنتيشن حتى سلايد ولا سلايدين فقط للسيستم اللي اختاره وليش اختار السيستم هذا. وبعدين بتتقسموا على مجموعات من 2 إلى 3 طلاب، يعني قد يكون المجموعه عندهم اكثر من فكره فيستقروا على فكره واحده من الافكار اللي معاهم. هذا نظامي في المشاريع، انه نبدا الجميع لازم يعرض فكره، كل واحد منكم لازم يعرض فكره عن المشروع تمام. زي ما اتفقنا عنده 1 مينت فقط، عنده دقيقه واحده يشرح فيه السيستم وليش اختاره. وبعدين اللي بنبدا بالخطوات اللي تكلمنا فيها اليوم في المحاضره، انه بنبدا مثلا ايش كانت مثلا الاحتياجات اللي ادت الى مثلا انه هذا السيستم تم انشاؤه مثلا. هذه اشياء بتاخذها من مثلا اذا اخذت مثلا من شغلك من الشركه، هذه الاشياء بتكون موجوده جاهزه. او اذا كان اخذت مثلا عجبتك فكره نظام معين بتروح تبحث عن النت مثلا ايش الاحتياجات اللي مثلا ليش النظام هذا تم انشاؤه، وبعدين بتدخل بالتفاصيل اللي هي مثلا في الكونسبشوال ديزاين، في الديتيل ديزاين، في البرودكشن ستيج، في الاوبريشنال ستيج، واخيرا في الديسبوزال ستيج. طبعا خلال هذه المراحل بتحتاج حكايتنا مثلا كيف نحسب الريلايبيليتي، كيف نحسب الكوست، كيف نسوي استيميشن للكوست. قد نحتاج مثلا نسوي موديلنج كماثيماتيكال موديلنج او سيموليشن ونسوي تحليل، يعني قد تحتاج الاشياء هذه وانت معك وانت ماشي يعني. بس المشروع بيكون خفيف، يعني بتاخذوه يعني على حكايه مثلا 15 ورقه بالكثير مع الابندكس والاشياء هذه. قد يكون مثلا الابندكس غير داخل في الحسبه، بيكون مثلا 20 ورقه. خلاص هذا يكون المشروع. الفتره مضغوطه، مش تيجي بعدين نبدا بالمشروع والكل بعدين يبدا يتدمر انه ما فيش وقت، لانه انا عارف احنا الان بنمشي تقريبا المفروض نخلص في شهرين.
يا دكتور
محمد الخطيب
يا دكتور
you can talk محمد you can talk yeah.
تفضل معك
يا دكتور.
تفضل
يا دكتور.
خلي محمد عشان رافع يده، بس خلي محمد يتكلم والباقي كلهم يقفلوا المايكات بالله لو سمحتم.
ايوه بالضبط. هو هذا الموضوع اللي اشتيه انا، لانه في ناس يراسلوني الان بالواتساب على الخاص بانه كل ما زادت عدد المايكات بدا التقطيع بالصوت.
قد انا احاول اكلم الشباب لكن
ايوه، فالافضل يعني نبدا من الان كلنا على قانون موحد بانه اي حد عنده مداخله يرفع يده اولا، بعد ما يحصل على الاذن يطلع على اما يعني كل واحد كذا يطلع مايك مباشره يقفز قفز وطلعوا 4 أو 5 اشخاص يبدا الصوت يقطع عندنا.
تمام حاضر.
فأتمنى يعني الجميع
الجميع
أتمنى
يلتزم
الجميع يعني بالضبط. شكرا.
باذن الله. عفوا. يبقى في الاخير الفاينل انا بالنسبه لي الفاينل دائما افضل يكون 50% عشان اعطيكم يعني اعطيكم اكبر قدر ممكن من الاسئله، لكن اذا كان الفاينل اقل من كذا يصير صعب ناخذ اسئله كثيره فيه. فهذا التقسيم اللي انا اقترحته. اذا كان حابين نشيل البروجكت ونحط ميد تيرم لازم تكلموني انا عشان اجهز كل حاجه وبعدين ارسلها للدكتور مختار او ارسلها
يا
لي.
دكتور خليني اخليها مناقشه نناقش به بعدين بالمجموعه، نشوف مع الشباب ونتفق على كذا ونرسل لك بالخلاصه، ممكن انت تطلع عليه بالمجموعه الخاصه بعد.
طيب حاضر، لانه اذا بنبدا بمشروع في ديدلاينز للاشياء هذه، فانا مرتبها على فكره في السلايد اللي بعد. خلينا ندخل على السلايد اللي بعده ونرتبها. المهم ما فيش حد عنده اعتراض على التقسيم هنا ولا لا؟
وجهه نظر.
خلاص. والكل سجل لنا يوم الاربعاء بنبدا من 4 ل 7، عشان بس عندي شغله مهمه بعد الساعه 7.
من 4 ل 7 اوكي.
يوم الاربعاء القادم فقط. بس يوم الاثنين بتكون زي ما هي من 7 ل 10. بكلمكم على الواتس لو في اي، لو يعني هي لسه يوم الاربعاء، لو تكنسلت الامور اللي مشغلتني يعني بنرجع على الوقت الطبيعي. اوكي. محمد he raised his hand so he can talk.
ثانك يو دكتور. بس
نعم.
بالنسبة لموضوع التوقيت، احنا الآن اتفقنا على 7 إلى 10. طبعا اليوم الإنترنت ما شاء الله شغال تمام وكل شيء
انا قد
شغال
مستغرب
معنا.
الامور ماشيه تمام.
أيوة. لا هو أمس تقريبا الساعة 1 بالليل، اليوم الساعة 1 بالليل غيروا كل شيء في النت كله، يعني علشان مواضيع سياسية. ف أتمنى يعني إنه يستمر النت كذا.
ادعي للحوثي وربنا شفتها.
فإذا رجعت الفلاتر يا رأفات، إحنا قلنا لو سمحت ارفع يدك قبل ما تطلع المايك. فإذا رجعت الفلاتر زي ما كانت من قبل، يعني في أشياء كثير محظورة، حتى مواقع الشات هذه والكل ما تقدر تدخلها نهائيا بعد المغرب. فمش عارف يعني
عندي أي مشكلة نبدأ من 4 ل 7 برضه. 4 ل 7 بالنسبة لي مناسب.
3 يا دكتور قد
مش
أفضل.
مشكلة برضه يعني.
لا أكثر من كده معناته أنا مش هرقدش. فاهم لكم قصدي؟ عشان فارق التوقيت بضطر اجلس سهران عشان اعمل لكم المحاضره، بعدين ارقد بعد الظهر ولا بعد ما اخلص المحاضره. فالى حدود 4 إلى 7 تقريبا انا ممكن امشيها، او حتى 3 إلى 6. 3 إلى 6 برضه ممكن تمشي اذا لاحظنا انه في مشاكل. فخلينا كمان نقرب يوم الاثنين برضه نفس التوقيت من 7 ل 10 نقرب كيف، واذا كان لا سمح الله يعني حصلت اي مشاكل بنأجل الامور هذه. اوكي
تمام دكتور تمام. بس انه اوكي نشوف الموضوع خلاص دكتور زي ما قلت من 7 ل 10 نشوف بقيه الطلاب ان شاء الله.
اذا كان الكل شايف التوقيت سيء ما عنديش اي مشكله نغيره يعني. قلت لكم عاملين تقريبا اذا الشباب اللي شغالين دوامهم ينتهي مثلا على الساعه 2 او 3 نعطي لهم مثلا ساعه مثلا يرتاحوا ويرجعوا البيت، فممكن نبدا من 4 اذا كان الدوام ينتهي الساعه 3 او مثلا من 4 نبدا، او اذا انتهي 4 نبدا من 5 يعني نعطيهم ساعه يجهزوا نبدا من 5. انا مش عارف لازم هذا الشيء تم مناقشته بالجروب تبع الواتس عشان الجميع.
يا دكتور انه في مجموعه كذا ومجموعه كذا، في مجموعه يشتغلوا ليل وفي عصر وفي صباح وفي كذا، يعني باي طريقه وفيكم في ناس يعني غصب عنهم يحضروا باي طريقه كذا ولا كذا.
في ناس متضررين يعني.
في ناس متضررين، فانا كنت اقترحت انه يوم بيوم يعني يكون يوم وقت مثلا بدري من 3 لين كذا، ويوم يكون من 4 ل 7، بحيث انه يكون عدل بينهم الاثنين.
طيب هذه ان شاء الله تناقشوها بينكم البين على الجروب ونحاول نشوف لها حل. ما لم سنستمر 7 إلى 10 وامركم الى الله. لانه صعب نسوي ناخذ كل الاعتبارات في نفس الوقت، ناخذ كل القيود في نفس الوقت. صحيح فعلا. تصير يعني المساله صعبه الحال، ونبدا ندخل في حكايه يعني الانفيزيبيليتي وندرس ان شاء الله في الماثيماتيكال بروجرامينج في الفصل السابع.
اوبتيمال سوليوشن يرجعوا خلاص.
ايوه اوبتيمال سوليوشن يصير صعب ايجاده لانه ما فيش اصلا.
صحيح.
من كثر القيود المفروضه. تمام، خلونا نخفف القيود عشان نقدر نحدد المواعيد.
صحيح. خلاص ان شاء الله دكتور وليد ان شاء الله ما
طيب،
قصرت.
بالنسبه للبروجكت وهذا زي ما اتفقنا في جدول معين لازم نمشي عليه اللي هو هذا. فلو قلنا اوكي للمشروع من ناحيه انه البروبوزلز لازم تكون موجوده يوم الاربعاء القادم.
خلاص بنناقش هذا مع الواتس، وايضا ناخذ راينا
انا قصدي يوم الاثنين قبل يوم الاثنين لازم يكون في قرار عشان نقرر نمشي ولا ما نمشي، لانه ما بيكونش عندكم وقت بعدين تحضروا اللي هي الصفحه اللي هي ال1 بيج ديسكريبشن. لازم يكون في 1 بيج ديسكريبشن للسيستم اللي بتختاروه. هذه بتحتاج لها وقت، يعني يحتاج لها يومين 3 ايام تقريبا. فلازم تجهزوا كل شيء قبل
ويب بيج يعني على النت.
لا بتكتبوها وترسلوها لي.
اوكي.
وفي نفس الوقت بيكون معك برزنتيشن خفيف لمده دقيقه توضح لنا ايش النظام اللي اخترته وليش اخترته. هذا بيكون يوم الاربعاء، يعني بحاول يوم الاربعاء انه المحاضره تكون خفيفه شويه عشان نقدر نسوي المناقشه تبع المشاريع. اذا اخذنا المشاريع معناته انا برتاح كثير بوقت المحاضره، يعني عندي المحاضره الثالثه تقريبا والمحاضره اللي في المنتصف هذه والمحاضره الاخيره هذه كلها رايحه للمشروع. فاذا اخذنا المشروع من المعادله بيصير عندنا وقت اكثر لنناقش اشياء كثيره خارج الاشياء المقرره هنا. يعني اقصد اذا احتجتم مثلا شويه توضيحات في الاشياء الرياضيه هذه.
طيب يا دكتور، بس انه لو كان مشروع يقترح انه حيكون يتاخر عشان احنا لازم نفهم الماده عشان نروح نسوي المشروع.
في البدايه اختيار النظام مش مهم تفهم الماده بشكل كامل، يعني اختيار للنظام، لانه اتفقنا انه النظام لازم يكون الخواص تبعه تعرفنا عليها وهذا اليوم. فبالامكان مثلا تختار سيستم تنطبق عليه المواصفات، انه السيستم هذا عنده سب كومبوننتس، عنده كومبوننتس، السيستم يقدم خدمه معينه، الكومبوننتس هذه متصله في بعض عشان تسوي الخدمه هذه والكلام هذا. فهذا صار تقريبا واضح. يعني ممكن حد منكم يختار مثلا نظام معين ونبدا نشتغل عليه، او يبدا يعطي لنا مثلا فكره عن النظام هذا. فكل طالب لازم بيعطينا هذا الجزئيه، وبعدين بتقسموا الى مجموعات من 2 إلى 3 وتختاروا الفكره الافضل ما بينكم البين وترشحوها بعدين خلاص تستمروا فيها. بالنسبه للمشاريع وهذا الليست تبع المحاضرات، او خلينا نقول اللي هي الاوفرول سيمستر بلان. عندك الاساينمنت مثلا متى مطلوب، هذا خلاص انا برسل لكم فقط تذكير مثلا في يوم 8 فبراير اساينمنت رقم 1 مطلوب منكم، الاساينمنت رقم 2 تقريبا مطلوب في 6 فبراير والكلام هذا، عفوا 24 فبراير. تمام. المناقشه النهائيه بتكون مثلا في 1 مارس، المناقشه النصفيه للمشروع بتكون مثلا في 10 فبراير، المناقشه المبدئيه والبروبوزال اللي اتفقنا عليه والون بيج ديسكريبشن بيكون في 27 جانوري. تمام. وبقيه الاشياء عباره عن محاضرات. فهذا تقريبا الاوفرول بلان. وعندنا كمان الكورس اوبجكتيفز، ما عم بدخلش بالتفاصيل هنا، يعني بالاول والاخير الغرض هو انه نعطيك فكره انه how to develop a system engineering plan for a realistic project، وهذا اساسا اللي بنختاره في المشروع، ونبدا نطبق الاشياء اللي ناخذها في الكورس واحده واحده، من الحكايات اللي هي ايش البروبابيلتيز والاشياء هذه المتعلقه بالايكونومكس والريلابيلتيز، وكيف نتعرف على الريسبونسابيلتيز، وكيف نطبق اللي هي التولز مثلا اللي بناخذ تقريبا اللي هو عباره عن واحده منهم تقريبا هي الديزاين ستراكشر ماتريكس بناخذها في التفصيل، البقيه عباره عن اشياء سهله والاشياء البقيه هذه. تمام. الكورس ماتيريال هذه اهم نقطه. بالنسبه للتكست بوكس بتقدروا تحملوها ولا احطها على جوجل درايف؟ ولو حطيناها على جوجل درايف بيكون في مسؤوليه حكايه اللي هو الكوبي رايتس والاشياء هذه، فاعتقد نخليها لكم تحملوها، يعني كل واحد يدبر راسه. تمام. التكست بوك الاساسي هو هذا اللي هنا، وبقيه البوكس هذه اللي انا قاعد اعتمد عليه في البرزنتيشنز على فكره، اي كتاب اخذ منه شيء اخر اسويه في السورس عشان لو حبيتم ترجعوا للكتاب. تمام. هذه الكتب الاخرى احتمال اعطيكم شويه اللي هو عشان الريدنج بجانب الليكتشرز، ممكن يكون في اللي هي التكنيكال بيبرز، اذا مثلا دخلنا في مواضيع تحتاج الى حاجه زي كذا ممكن ارسل لكم مثلا ورقه علميه معينه نحاول نقراها ونناقشها في الفصل، يعني بيكون ورقه الى ورقتين في كل سمستر تقريبا. نجرب اول شيء اول مره، واذا كانت الامور كويسه بنستمر، اذا لا معناته خلاص بنوقف ونعتمد على الكتب والبرزنتيشن فقط. الاكسرسايز وضحتها لكم انه بتكون عباره عن يعني في كل محاضره غالبا، وبختار فقط افضل 5 منهم، فنحاول نقرا ونحاول نجي المحاضره جاهزين عشان نقدر مثلا نرد على الاكسرسايز هذه ونشوف انه مثلا طلعنا كويس فاهمين المحاضره هذه ولا لا، عشان انا اعدل اموري. هذه هي بالنسبه لي اساسا، وبغض النظر ايش ما كانت درجتك في الاكسرسايز، اي حد حضر الاكسرسايز بياخذ الدرجه الكامله بشكل عام، لكن فقط هذه عشان التقييم وعشان اعرف مثلا ايش اللي لازم نعدل فيه وايش اللي لازم نشرحه بشكل اكثر. الكورس بروجكت تقريبا ناقشناه في التفصيل زي ما اتفقنا. 5% من ال 35 بتكون للون بيج ديسكربشن مع البرزنتيشن، وعندك 10% بتكون للميد تيرم تيم برزنتيشن، و20% للفاينل تيم برزنتيشن. والملف فيه كل التفاصيل، ايش لازم يكون مثلا السكشنز اللي لازم تكون موجوده في الريبورت تبعك، وكم الريبورت والفونت والفونت سايز والاشياء هذه كلها موجوده في الملف الخاص بالبروجكت. هذا تقريبا كان كل شيء. اللي حابب انا اتكلم فيه بس انه يعني حابب اشكركم اليوم على الحضور بصراحه، والحمد لله انه النت يعني كان نوعا ما كويس،